Depending on your geographical location, good morning, good afternoon, and good evening. Respected guests, esteemed senior scientists, and the vibrant community of young researchers joining us virtually from every corner of the globe, ladies and gentlemen. It's a distinct honor and a matter of great privilege for me as the Secretary of the Institute for Mathematics, Bioinformatics, Information Technology, and Computer Science. In short, we call it IMBIC, to extend a warm and cordial welcome to you all. We are gathered here to inaugurate the 19th International Online Conference on Mathematical Sciences for Advancement of Science and Technology. In short, we call it MAST 2025. As many of you are aware, IMBIC is an international organization with proud branches in Sweden and Japan, dedicated to the interdisciplinary advancement of science. As we begin this three-day journey, we do so with a profound sense of remembrance. It remains a great shock and an immeasurable loss to all of us that our founder, president, and the pillar of IMBIC, Professor Dr. M.R. Odhikari, passed away on 29 June 2021. Professor Odhikari was a remarkable visionary who remained academically active until his final days. His ever supportive, encouraging, and loving nature ensures he will always remain in the hearts of everyone he touched. It is in his honor and following his vision that we continue this legacy today. As the Secretary of IMBIC, I would like to share a few words about our institute. Founded in 2006, IMBIC is relatively young compared to the rich history of Kolkata, but its impact has been significant. It was established under visionary leadership of Professor Dr. M.R. Odhikari of Calcutta University, Professor Dr. Eric Trell of Linköping University, Sweden, Professor Dr. Y. Shikata, Nagoya University, Japan, myself, and 10 dedicated founder members. Professor Odhikari's dream was to create an international platform where researchers could engage in interdisciplinary dialogue, recognizing that modern sciences are deeply interdependent. His tireless efforts to organize his annual international conference will continue to inspire generations for scientists. His aspiration transformed this institute into a vibrant hub for research in mathematics and mathematical sciences, both in India and abroad. A primary goal of IMBIC is the publication of high-quality scientific research. To this end, the institute facilitates to publish the esteemed proceedings and monographs annually. Notable works communicated through IMBIC include Basic Modern Algebra with Applications by M.R. Odhikari and Abhishek Odhikari, published by Springer in 2014, Basic Algebraic Topology and Its Application by M.R. Odhikari, published by Springer in 2016, the 2017 commemoration volume, Mathematical and Statistical Applications to Life Sciences and Engineering, edited by Abhishek Odhikari, M.R. Odhikari, and Y.P. Chobe. The 2013 IMBIC monograph, Contemporary Topics in Mathematics and Statistics with Applications, featuring contributors from the US, Canada, Japan, Germany, Switzerland, and India. Basic Topology 1 and Topology 2 in 2022 by Abhishek Odhikari and M.R. Odhikari, published by Springer, and Basic Topology 3 in 2023, authored by Professor M.R. Odhikari and published by Springer. In keeping with this legacy, I am pleased to announce a new commemoration volume as a tribute to Professor Odhikari's memory. This Scopus Index volume, titled Quantitative Frontiers exploring applications of mathematics and statistics, is scheduled to be published by Springer in January 2026. Our annual conference remains a cornerstone of IMBIC's activities, highlighting specialized topics across mathematics, statistics, computer science, and bioinformatics. This year, in response to our call for papers, we received 125 research contributions from scientists across 4 continents: Asia, Europe, North America, and Australia. Within India, we saw participations from 18 different states. Following a rigorous review process, only 19 full papers have been accepted for publications in the proceedings of IMBIC Volume 14. Over the next 3 days, we are privileged to host a truly global assembly of academic and industry leaders. We are fortunate to the to be joined by esteemed scientists from prestigious international institutes, including Professor Erik Trill from Linköping University, Sweden, and Professor Manos Chatterjee from Birmingham University, USA. Our academic discussion will be further enriched by the researcher from the University of Illinois, University of Chicago, University de Polytechnic de Catalonia, Barcelona, Spain, and Lund University, Sweden. From the industrial sphere, we are honored to welcome leading experts from IBM Research USA, Fujitsu Research from America, and SWAF Inc. A significant highlight to this program is our 3-day online workshop, Data Science Accelerate Your Career, conducted by top-tier industry practitioners. We are delighted to have Bishwajit Pal, Director of Data Science Nuven, delivering sessions on the end-to-end machine learning lifecycle and agentic AI, the math behind the magic. We also have Abhishek Sengupta, Principal Data Scientist, Walmart Global Tech, exploring the mathematical foundations of GenAI and building local GenAI agents. Shumon Pal, AI/ML Decision Science Senior Manager, Accenture, presenting on unleashing the power of optimization. This combination of theoretical depth and practical industry application ensures a truly fruitful experience for all participants. On behalf of IMBIC, I express my sincere gratitude to all invited speakers, participants, committee members, reviewers, and authors. Whether your paper was accepted or not, your contribution to the scientific dialogue is deeply valued. I am confident that this conference and the workshop will be fruitful and enriching experience for all of us. Thank you. So with that, may I now request Professor Erik Trill, Emeritus Professor of Linköping University, who is the Vice President of IMBIC and Director of Sweden branch of IMBIC, to deliver the inaugural address. Now, Erik, it's yours.
Oh, thank you so much. Hello, everybody. It's so nice to be back again, and it's becoming a lot of years now, adding experience and sharing thoughts and views and somewhat new results also. And it is a fact that I'm also a medical doctor, and originally we thought we should have a bit more medical things in the schedule, but it's time again for that. And it's then with great joy I can share that our daughter, Christina, has joined our forces, and that will increase capacity on the medical side. I have presented the results earlier on that the so-called healthometer, and things are now that medicine is becoming more expensive again. Expansive, not expensive, but that is becoming the too, of course. And it has a lot to do with communication, and what also enters the scheme is artificial intelligence. So we have a lot of eras that have passed during my time here, and now we are in the age of artificial intelligence, they say. And this brings a lot of topics to the agenda, and my particular interest now is medical computing and informatics, a bit more from the medical point of view. And certainly a lot of ideas spring if one can also use artificial intelligence in that. That would bring a lot of nice work, I mean, and activities, and is about to happen more, I think, and hope. But this year, again, is it my long-term studies here under initially Mahim Adhikari, whom we all miss so much, but also have so nice and loving memories of, and whose spirit still lives here, and Avishek, who really carries on the work. And we have complemented each other in a way, because you are the masters of topology, but I can contribute a bit in the area of topography. And this is a nice complement with common roots, and among these, the big Sophus Lee shines, and his light is coming stronger and stronger again now. And in that respect, my present contribution is a bit culminative, and may allow me to go to new fields, perhaps, including the medical ones. And this will be paired with some perhaps more not commercial but public activities, where IMBIC might get a bit more illumination share in the events of Sweden. So this is something that I would like to announce and see which comes first, age or progress. But that we now have Lena and Christina more in the team brings me satisfaction and hope. And now I just announce this. Yeah, it's very nice and also a bit moving to be back each year. And it's so nice that it happens at all in this world. There are so many problems now, and but I think that our spirit there is to stay and persist, and say thank you again for having me here, and bless you all, would I say.
Thank you,
Thank
Eric.
you.
Thank you, Eric, for joining with us, and thanks, Lena, as well, for joining with us. So though you can see that in the participation list, there will be very few participant joined in our Google Meet link, because we have shared to only very few participants for this Google Meet link to handle it properly. But mostly more larger number of participants will join over our YouTube link that we have already shared to all of you. So those who are viewing us through this YouTube link, we welcome you all, and please stay with us. And we are going to share the feedback form soon. After some intervals, we'll continue to do so to share your feedback so that we can provide you the certifications and properly. The data science workshop will start soon. But before that, it's my great pleasure to welcome Carl Soup from Soups Inc., Color Research from US, to deliver the address of guest of honor. Now, Carl, the session is yours.
Okay. Okay. Can you hear me okay?
Yeah, it's
Um, I'd just like to start off saying thank you for inviting me and with me being able to participate and hopefully contribute to the math conference. Regarding the main objective of MAST, I represent one of those specialized topics in mathematics. The presentation of my papers at MAST helps promote the sharing and collaboration of outside the box concepts of color theory in a supportive environment. I see it as being in the IMBIC family. Being associated with IMBIC has helped change my perspective of the world, and I've kind of gone from looking at things in terms of I and me to us and we. I've realized that my research is not about me or how I will benefit from it. My research is about us and how we can benefit from it. Since I've been involved with IMBIC and doing research, some of the things that I've developed with my research is color theory, which is color expressed as numbers in geometry. I've come up with 10x circular constants. I've heard that expressed as being opposing circular constants. I've developed Jacob's ladder. It's a harmonic distribution based on the golden ratio. I've developed color harmonics based on Jacob's ladder. Color music theory, where I'm taking the circular fifths based on Jacob's ladder, and color octaves that are correlated to color harmonics so that I can express color in terms of musical tones or musical tones in regards to color harmonics. And now I'm using that, what I've discovered, to develop a temporal theory where time is something that we measure in terms of 1 second. And it's timekeeping, but it's not time itself. And most of our engineering and scientific equations deal with time being 1 second. And if we can understand what time is itself, it may help us understand where we are in the universe or what the universe is all about, which kind of culminates in another discovery I'm trying to develop called the crystalline multidimensional fabric of space. So it's just a way of trying to explain what the cosmos is. So me being here, I'd like to share a little story with you. I won't take a whole lot of time. My interaction with Professor M.R. Adhikari began with a paper I co-authored with the late Professor Michael Vanook called the Carl Series. Professor Vanook hailed from the University of Wisconsin in Milwaukee, and Professor Vanook was working at the NASA White Sands Test Facility during the summer. Professor Vanook invited me to assist him in presenting our paper at a math conference being held by the Calcutta Mathematical Society. I accepted his invitation, but weeks before the math conference was to be held, Professor Vanook told me that he couldn't attend the math conference. He felt that I knew the material and that I should go in his place. At first, I didn't think he was serious. In the end, I was on a plane by myself heading to Kolkata to attend the math conference being held by the Calcutta Mathematical Society. Once I arrived, someone was going to pick me up at the airport. My flight must have been the last one to arrive. It wasn't long before all the other passengers were gone. I was left sitting in the airport by myself. I kept thinking, you are a long way from home. It was Professor Dr. M.R. Adhikari that picked me up at the airport. I liked and trusted him from the moment I met him. He kept inviting me to the math conference, and I kept coming. That happened more than 2 decades ago. Now I'm invited to submit a paper and participate in the math conference by Professor Dr. Avishek Adhikari, Secretary of IMBIC, and it is always a great honor and pleasure for me to present my research at MAST in international venue. The point being, sometimes we must push ourselves beyond our comfort zone to grow. Thanks to Professor Michael Vanook and Professor M.R. Adhikari, we have my color research leading to a possible theory of time itself. And it just shows that mathematics is truly a universal language. So in concluding, if my assumptions and theories are sustainable and I have the right set of values for Earth equals 1, there's a lot that can be developed from that. And it all came about because Professor Vanook sent me to present a paper, and Professor Adhikari picked me up at the airport and looked out for me from that first time and for every time after that. He was always there looking out for me, and I greatly appreciate it. So thanks for that, and thanks to Professor Avishek Adhikari, Professor Trell, the program committee, the organization committee, the executive committee, and all the individuals and organizations who have helped make the yearly math conference possible. This includes the individuals and teams that have submitted papers to the math conference. You are greatly appreciated. And for those attending the MAST 2025 conference, thank you for your interest, support, and participation in this year's conference. Thank you.
Thank you, Carl, for your supportive words and nice words. We are really thankful to all of you. So we have a branch in Japan. Professor Y. Shikata is the currently director of that, but due to his illness, he explained us that he is unable to join this online meeting, but maybe in future he will join us. So it's my time to request Mrs. Minoti Odhikari, Treasurer IMBIC, to deliver the vote of thanks.
Good morning. Good afternoon and good evening to all the dignitaries, participants, and interested persons participating in the 19th 3-day online international conference MAST 2025 organized by Institute of Mathematics, Bioinformatics, Information Technology, and Computer Science, in short, IMBIC. On behalf of IMBIC, first, I would like to pay homages to Professor Dr. Mohim Ranjan Odhikari, an eminent mathematician and founder president of IMBIC, founded the institute in 2006 with an aim to provide a platform where the researchers and scientists in different areas of mathematics and mathematical sciences heavily depend on each other, share their valuable thoughts and opinion for further development. It is our pleasure when we see that his dream comes true. IMBIC has crossed just 19 step by step, spreading its branches all over the world, keeping its head held high. His blessings is always with us. He will be alive in his works and creations. The inaugural ceremony we have been watching and enjoying is now coming to an end. Before concluding the session, I have the opportunity to convey vote of thanks to the chairman of the session, Professor Dr. Abhishek Odhikari, head of the Department of Presidency University, Kolkata, West Bengal, India, and the founder secretary of IMBIC, who in his vibrant inaugural speech enlightens us on the importance of interdisciplinary scientific research works, and in this regard, the role of IMBIC for promotion and extension of mathematical knowledges in different areas. We, the IMBIC family, especially convey our thanks to Professor Dr. Eric Trell, Emeritus Professor of Linköping University, Sweden, founder Vice President of IMBIC, and the Director of IMBIC Sweden chapter, for his motivational speech, which is very much inspiring and instigates the young generations. He, from the very starting of the journey of IMBIC, is closely associated with IMBIC family and has been working spontaneously as a senior well-wisher of the Institute. We wish him a long, healthy life. On behalf of IMBIC, I sincerely convey my thanks to Carl Soups from Soups Inc. USA, who in his inaugural speech shares his wise thoughts and ideas that will open the door to the new researchers and instigate them to enter into the deep. From the very beginning of IMBIC, he is also closely associated with IMBIC family. IMBIC is thankful to him for his assistance in every phase. We convey our thanks to the dignitaries and the participants who, with their thoughtful presentation, will share their views and thoughts in the conference. We convey our thanks especially to the group of enthusiastic volunteers named Dr. Prakash De, Dr. Chandan Goswami, Himadri Shekhar Roy, Dr. Sandip Mondol, Suchandan Ghosh, Niloy Das, Neha Bagh, Dr. Kumar Deep Bose, Nayantara Ghosh, Subhashish Nalui, Sandeep Haldar, Rajibul Haq, Shamik Chatterjee, Parnabo Ghosh, who, with their skill in modern technology, have been working relentlessly with utmost efforts and sincerity to conduct the 3-day conference as well as workshop through online as smooth as possible. Their dedication to the work, we must hope, will lead the conference to the extreme height. At last, but not least, I just, on behalf of IMBIC, conveys thanks to Master Obhipriya Odhikari, the youngest scientist of IMBIC family who, despite his busy schedule for ensuing board exam, helps IMBIC in many ways behind the screen. We are all wishing him all the best in his exam. Thank you all.
Thank you very much for this vote of thanks. So that's the end of our inaugural ceremony. So very soon we'll be going for our next technical session. So there will be 4 different parallel sessions. The main session, those who are with this YouTube link and this session, so they will be with data workshop that will be coming soon from 5:30. It will start. And other 3 parallel sessions, that would be the paper reading sessions. So we have already shared with the participants the corresponding links of every different parallel sessions. Please go to the PDF file. There we have already mentioned the link of your session. The session chair will join shortly and they will guide. But before that, please, the volunteers are already there. So they are going to help you in every aspect. So if you require any help, please contact them. They are already there. So may I now request all the participants who will be presenting in the upcoming 3 parallel sessions are requested to visit the corresponding link. Those who are in YouTube, they please stay here because this session would be broadcasted through YouTube, and the paper reading, not the paper reading, the data science workshop will be starting soon. I'm sure that the speaker will join us, Abhishek Shengupto. He will be joining us. Might be he is here. Abhishek, are you here? Okay, so I'll just contact him.
Yeah, I'm here.
Oh, Abhishek is already there. So you can start sharing your screen. We'll be starting maybe 5 minutes, maybe.
Sure.
Yeah. So, and so all the others who want to stay here is fine. But those, if you have paper reading session, so please go to other link. They're the the other volunteers. They're going to help you out there. So I'll just be. So Abhishek, you can start the sharing your screen. So yeah, just one announcement to the participant who are using your YouTube link. So we are going to share the feedback form periodically, so you have to fill it up. We'll provide the participation certificate to all the participants who have significantly joined there. Also, there will be a completion certificate for data science workshop. So we are going to take an exam, an online exam on the 3rd day of the workshop. That means on 23rd of December. So there we'll have an exam, online exam. Those who will be getting more than 50% or at least 50% of the score, they will be providing an extra certificate of completion of the workshop, data science workshop. So 2 separate things. One is participation certificate. Those who will be participating the conference significantly, that means filling up our periodically given that feedback form, those will be filling up properly. They will be getting the participation certificate of the conference, including the workshop. But those who will be getting score more than or greater than equal to 50% of the score of an exam to be held on 23rd of December after the end of the 3rd lecture on data science will take an exam. Those will be scoring more than or at least 50% of the score. They will be getting the completion certificate of the data science workshop. So may I request all the YouTube viewers to stay with us. And I can see that already there are plenty of participants who are joining using our YouTube link. So it's our great pleasure to welcome you all. So please stay with us. And I think it's just time for Abhishek. Maybe, are you ready, Abhishek?
Sure, I'm ready.
Okay, so 2 more minutes, maybe.
Yeah, absolutely. I'll meanwhile just start sharing my screen maybe.
Yeah. Yeah.
My screen is visible, right?
Yeah. Your screen is perfectly visible and your sound is also clear. So it's now great pleasure for me to welcome Abhishek Sengupta, the principal data scientist, Walmart Global Tech. And as you can see that the title of his presentation would be Genetic AI, the maths behind the magic. And so without any further delay, it's my great pleasure to one of the great leaders, young mind of data science. So it's my great pleasure to welcome Abhishek, the same name that I have. So please, the session is yours.
Thank you so much, Professor Adhikari. And it's a great pleasure actually to come here again for the second time and presenting one of the things that I'm very closely involved with nowadays, and I guess everybody is, which is Agentic AI. So what I wanted to do is that since Agentic AI is all the craze right now, right? So, and people consider this as sort of a black box and a magic box where everything, I mean, you put in some data, you put in some question, it automatically fetches the answers for you. It curates it in a particular way that you want it to, and everything is done, right? So, what we want to do as part of this session is, instead of just fantasizing over the magic, we also want to go a bit deep into the math behind what powers agentic AIs and LLMs in general, how it's different from a traditional simple deep neural network from which we started, delve a bit deep into the transformer architecture, which is the core of any LLMs. But before all that, what we will do is that have maybe a very short, fun, hands-on demo that we can cover maybe in 15 minutes, wherein I'll try to show you how, in a simple local setup, you can just set up your own agentic system, keep on adding more and more tools, start from very simple applications, and then build on top of it, and then go to much more complex applications. After that, I'll go to the architecture. So the architecture for this entire thing remains almost the same. So I'll just basically go into what are the different components, such as your attention mechanisms, positional encoding, layer normalizations, and all those things that powers this entire LLM Gen AI architecture. And also I'll try to talk again, talking about the maths behind it I might not do it justice if I just have to cover everything within 1 hour 15 minutes, but I'll just try to touch upon the basic concepts. Yeah, so that will be the agenda for this roughly 1 hour 15-minute talk. So without further ado, maybe I'll just start with the introduction. So firstly, what is agentic AI? I guess, I mean, all of us know the answer to this question, but more often than not, I've also been asked questions that what's the difference between a typical LLM and an agentic AI? What is the difference between generative AI and agentic AI, so on and so forth, right? So in short, AI systems are systems which can automatically or autonomously, I would say, perceive, plan, reason, and execute complex tasks. This task can range from simple tasks to multi-step tasks. And the idea is that you don't have, or you have minimal human intervention, right? So it can autonomously perform certain tasks, right? So unlike the traditional AI that responds to prompts, right? So you give a prompt, it's a one question in and one question out. What agentic does is that it takes initiative and adapts dynamically to changing environments, right? So essentially, suppose I'll just give a very quick example, that suppose you want to ask chat GPT, right? That I want to make a plan for my December Christmas holidays trip, right? When agentic AI, or in those days LLMs or Gen AI started, you just get one answer. Okay, you have a plan, you want to make a plan in December. So, okay, this is the possible options that you can go and choose from. Now, what agentic AI is more powerful, so powerful that what it can also do is that it can not only suggest all these various options, look up your calendar, also find out these are the days that I have leave, these are extended holidays, these are the places where the price tickets are cheaper. So it can collate across your calendar, it can collate across external websites, where it can collate across what the weather is in a particular area that you want to visit, what the ticket prices are. It can combine all of them together, even though you have not asked the system anything. You just ask him to make a plan. So what it will autonomously do is that it will check in all these considerations and then provide a curated answer for you. So that's how Agentic AI has advented through this last 2 or 3 years. It's not been long since Agentic AI launched, but it has made rapid progress in these few years, right? So again, key capabilities, as I mentioned, autonomous. It decomposes these complex goals. It has a reasoning planning session or a loop in which it goes so that it can plan across everything. And it learns from feedback as well, right? So for example, I go back and say that, say weather is not a concern for me, I am willing to travel anywhere. So it will take that as a feedback. So in the future, within the same session, if you ask another question, it will keep this in mind and not take weather into consideration. So that's the beauty of and the key capabilities of Agentic AI. Applications, apart from the ones that I just mentioned, that is more of a personal use where I want to plan certain things out of my own, look up certain things and so on. In the industry, it has widespread application. I'm just listing 3 of them, but it has a widespread application across every frontier. Customer support is where these agentic autonomous systems play a key role, wherein it can be used to auto-resolve certain tickets, identifying trends, escalate issues which are in the queue for a long time, so on and so forth. In the supply chain industry, also, I come from Walmart, which is a retail chain. And then in supply chain, we are heavily using agentic AI systems to forecast demand, optimize the logistics, how an item should be shipped from your fulfillment center, from the distribution center to the fulfillment center to the store, so on and so forth. Again, detect anomalies in the supply chain route, so on and so forth. And the other thing that we also see a parallel evolution in the terms of Copilot is very common nowadays, right? So how can we automate code writing, right? So for all the basic tasks, if GenAI can generate code, write test cases for production, do production deployments, validate requirements, and so on and so forth. So the benefits and the potential impact or the projected impact. So the benefit is that the target is, right, so at least by 2028, overall, there is a global target that you automate 40 to 60% of the repeated tasks. Then your task completion and development automatically becomes 50% faster. Then the beauty of it is that there is no downtime, right? So if you have a server which which already has a dedicated instance of a GPT or a Gemini loaded in it, so there is no downtime. Whenever you go and try to resolve tickets, ask for questions, it's always up, right? And then this is projected to be a huge around 3 trillion, not even million or billion, 3 trillion potential GDP boost by 2035, leading to at least 50% reduction in costs in operations. And also it's by the next 3 years, so almost at least 1/3 of the industries and almost 50% of software or IT industries is expected to embrace agentic AI and then completely automate certain sectors of the system through agentic AI. So hopefully that gives an introduction about what agentic AI is. And then again, obviously, local desktop, because this requires dedicated GPUs, dedicated instances of PTUs or GSUs, which are essentially nothing but microservices of your Gemini or your GPT sitting in your system or sitting in a cloud. But for this exercise, what I am trying to do is that I'll just set up a very simple Google's version of this agentic system using something called an agent development kit. And what I'll do is that I'll go from very simple, just create a very simple agent, and then give the agent some additional capabilities by adding certain tools to it. I'll start with single tool, and then I'll just move to multiple tools. Okay. And then if anyone is interested, they can also follow through with me. There is nothing here. So I'll just show you how simple is it to build agents nowadays. So if you look at this particular, so this is just a Python notebook on VS Code, which I just have coded. And believe me, it took me, what, 15 minutes? Not even 15, 10 minutes to code this entire thing, right? So it's very easy to set up agentic systems nowadays, right? So I have just defined 3 agents in my system. So the first is my agent base, and I'll just come to that. And then we have my agent single tool call and my agent multi-tool call. If you open this, it has just ignore PyCache. Those are all caching systems. It has just 2 files, env and agent.py. That's it. And what is there in my environment variable? It just has the Google API key for calling my Gemini 3. So I have a Gemini 3 version. I just took a free version from Google. You can go to Google AI Studio and just get a key, and you can use this key. Or if you have purchased any professional version of either Google, GPT, whatever, or any open source, Claude, Anthropic, so you can use that key. There's no limitation here. So my environment variable just has the Google API key. That's it. Now coming to my actual agent, this is the second .py file. So what I'm doing is that I'm just install this library, which is Google ADK agents. I'm importing this agent. And then I just have to write, 4 lines of code. That's it. So I just mentioned which model that I want to use. I'm using Gemini 3 Flash preview because I just want it to be very lightweight. I just given the name of the agent, and then I've just given a description, right? So I've just given a description that this is a helpful agent which can answer user questions. I can also modify this, right? So a helpful agent for user questions on, say, movie ticket prices. I'm just randomly giving this. So now it understands that this is an assistant which is used for answering questions on movie ticket prices. And the instruction I'm specifically giving the agent is that answer the questions to the best of your knowledge. You can also augment it as you want. Now let's run this agent, right? So I have this terminal open below. So what I just do is that it's a simple command is ADK run, and then you just need to give the name of your agent. So the name of my agent is my agent base. So what I do is that I just do ADK and I run my agent. Now, because this is a local setup, this will take a little bit of time to boot up and then actually allow me to ask questions. But the idea is that simple, you just have an environment variable where you just put in your API key. You just have one file. And again, when I add tools into it, I can split them into multiple files. But right now, there are no tools into it. So you have this one file. I'm just importing from Google ADK agents. I'm importing this agent library. And then within this agent, I'm defining the model, the name, the description, and the instruction that I want the agent to do. Okay. So now this has run, right? Now what I can see is that as a user, I can ask a question. So let me see, what can you do? I'm just asking the agent, what can it do? That's it. So now what the agent should is based on the description and the instruction, it should give an answer, right? So now it says that, okay, so now it says, I am an helpful assistant designed to support you with a wide range of tasks. You can think of me as a versatile tool for information, creativity, and problem solving, right? Do note that it did not give me anything about movie ticket prices. It is very generic. So what went wrong here? The only thing that went wrong was I hadn't saved my file. So I had to save my file, and then I just had to rerun this. Then it would have given me the correct answer. So what I can do is that I can just go ahead and again run it. But instead of doing that, what I'll do is that I'll just go to the next step. Is that because this was very generic, right? So what I'll do is that I'll go to my second agent, which is called my agent single tool. So it has an environment wherein again the key is set, and then it has another agent.py class, right? So here what I've done is I've added a tool to that agent. What is a tool? A tool is nothing but an external. It can be an API call, it can be a REST call, it can be a retrieval call, it can be anything. It's an external function. Consider of tools as just functions, which allows the LLM to search. So how does an LLM find out things from your calendar? How does the LLM search the web and give you information? These are all through tools, right? So you have a fetch calendar tool, you have a fetch information from internet tool, so on and so forth. So obviously for this, I've just given a very small tool, which is nothing but a tool which gives the time in a specified city. That's it. right? So rather than depending on the agent's intelligence itself, I am offloading some parts of the agent into specific tools. In this case, I am asking the agent to fetch this tool in order to get the current time. So I've just changed the description that I'll tell the current time in a specific city, and then you are a helpful agent that tells the current time in cities. And I've also mentioned that when you need to fetch the time, use the get current time tool. So this is one tool, and then the agent has access to this tool, right? So how do I run this? Again, same way. I do a ADK run my agent base, but let me do one thing. So ADK again out of the box provides a very nice and clean UI which can be locally hosted in your system. So for that, you just have to run the code ADK web port 8000. So this agent or this UI will sit in your locally hosted system in the port 8000. And then if you just copy this URL link, what will happen is it will open up this wonderful UI. Now you see here, it asks me to tree the agent. So there is this old my agent base. Right now I'm looking at my agent single tool. Right. So now let me just quickly type in. Okay. So this tool is in progress. So let me just type in, what can you do? Yeah. So now it says I can tell you the current time in any city you specify. Just name a city. I'll look it up for you. This is exactly what I told in the agent's description, that it can help tell the current time in cities. So let me write, what is the time in New York now? So right now, if you see here, it called the tool get current time. Then this tool was invoked and it was successfully processed. And then it found out the current time in New York is 10:30 a.m., right? So this entire is something I've just hard coded. If you look at this tool, whatever city it is, it would have said that a time is 10:30. But in order to show this, I have just, you can see that it actually had called the correct tool and then it gave the correct answer. Okay. So again, this is one agent with one tool. And again, it's just less than 15 lines of code, which allowed you to deploy this. Let's take one step further. What about two tools? So now there is again one more folder here, which has my agent multi-tool. So here also I've defined an agent, and now I've added two tools here. So the first one is get weather. So this is nothing but it fetches the weather for whatever country I search for. And then I've just hard coded certain information that if it's New York, then you always mention that the temperature is 77 degrees Fahrenheit. If it's any other city, then you say that I don't have information for this city. And then get current time remains the same. So it tries to get the current time. Remember previously I had hard coded it to 10:30 a.m. But now I'm just doing is that if it has been identified as New York, you have the time zone identifier, which fetches America, New York's time zone, and then it gives the answer. Right. So the current time is the now. So it's the time at this particular time zone, and it gives me the answer, the actual time. So now again, my agent is saying what I have said is that you are an agent to answer questions about the time and weather in a city. And these are the two tools that you have access to. So now remember, now one thing to understand is that the agent now has to decide between which tool to call, right? So if I ask a question, what's the time and what's the weather in a particular city, it has to go do one fetch to get weather, do one fetch to get current time, again, without me explicitly telling it to do that, fetch the answers, culminate the answers, put them together and provide an answer, right? So let me do one fun thing here. So what I have done is, this is the question, right? This is the instruction. You are an helpful agent who can answer user questions about the time and weather in a city. What I'll do is that I'll just add one fine line and then see what it does, right? So I'll say that and maybe answer in a rhyming manner. So whatever answer you have to answer in a rhyming manner just to see how the agent performs here. So I click on save. And then again, I have this port already open for me. So I again go to the same port. Where is it? It's here. And then what I do is that instead of my single tool, I select multi-tool. And again, this UI has not been built by me. This is the default UI which Gemini or Google ADK directly provides. So now let me type in the question. So what is the time and weather? So I'm asking the agent implicitly to call two tools, time and weather, in New York now. Let's see what it does. So it's calling get current time, it's calling get weather. Both the answers were fetched. It processed them, and because I had asked the agent to answer in a poetic or in a rhyming fashion, so it says that the answer is in the form of a rhyme, right? So it's giving the answer. It says 7:18 in the morning, and it's 25 degrees. So it's answering in a rhyming manner. So again, this is a very, very simple basic template which allows you to add, again, I've just added two tools. There's nothing preventing you to add a third tool, right? So the third tool can be are there storms there? I mean, storm is still part of weather, but you can add any other tools, right? So what is the current traffic in a particular lane in New York, right? That can be a third tool. So you can keep on adding one after the other tools to this particular agent. Just add this tools here, and then so maybe a traffic tool, right? So once you invoke these tools, invoke this agent, it will automatically have access to these tools, and you would be able to get answers to the questions using these specific tools. Okay? Yeah. Cool. So this was the very short and a very quick demo about how agents work and how they interact with tools. So having completed this demo, I will just move back to my presentation. Cool. So we covered the Python demo. So now let's look at the architecture which powers this Agentic AI, which is an basic LLM or a transformer architecture. So before going into the actual in-depth LLM architecture, what I would want to do is a quick recap of where it all started from. So a base neural network, which is also called a linear network or a feed-forward network, it has many names, but it's a simple network. So you have an input layer, you have multiple hidden layers. I guess most of us are familiar with this structure. So you have input layers, you have multiple layers, which are often called hidden layers, and then you have the final output layer. So all your text gets embedded in my input layer, then it passes through multiple hidden layers, and then finally you have an output layer. And then there's this concept of weights and biases. So for each transformation, all the embeddings are multiplied by a weight, they're added with a bias, then pass through an activation function. Again, I'm not going into the details of this. So after transformation, it propagates through multiple layers, and then the final output layer makes a prediction. So mathematically, this is how it looks. So let's consider all the inputs as x1, x2. So each hidden neuron, these are called neurons, are nothing but a combination with different weights, and these weights are learned plus a bias. So these combination of these weights is what results in this hidden states, and then finally the hidden states are culminated into a final output. Again, I mean, for those who are not familiar, maybe they can read this up quickly somewhere, but this is the base of structure, and I'm not spending time on this because I'll focus more on the LLM part of things. What's extra there? Yeah, so essentially, if you look at it in the matrix multiplication sort of a way, this is how it looks like. So each of these values are multiplied with different weights to get the hidden layers, and the same thing happens through multiple hidden layers. And how are these weights trained? Again, I'll not go too deep into that because that's a backprop algorithm or backpropagation algorithm. For those who are not aware of this, again, you can just take a look at how it happens. So what happens is that we calculate the final error. So error between the actual value and the predicted value, and we try to minimize this. So we try to minimize this error function, which is the difference between your predicted and the actual. And this error is propagated back. That's why it's called backpropagation across all the hidden layers to the very first layer. And again, this is a very complicated equation of what backprop looks like. Not very complicated also. So essentially, you take the gradient of the errors and try to minimize the loss function. But I'll again not go into the details of this, but through a simple gradient descent algorithm, propagation through the layers happened. And this is how the errors are minimized and these weights W1, W2, W3 are learned. So this is the very basic neural network architecture. Now, a neural network architecture with softmax. Softmax is again one of the activation functions. So this is used when in the output layer wherein you want to predict the probability of a particular class, right? So a typical example being that you have an image, you're trying to predict whether it's an image of a cat or a dog or a mouse. So what we do is that we pass these images, obviously encode it and pass it. It passes through the layers, and in the final probability, it gives you the probability of whether it's a dog, whether it's a cat, whether it's a mouse. And the one with the highest probability is what that picture is assigned to. And this is the function of softmax. Now for this generative solutions, right? So wherein I'm asking a question and I'm expecting an answer, how does this fit in? So for generative models, it's nothing but highlighting the next word. So I've asked in a question, what should my next word be? What should my word next to it be? So on and so forth. So when I ask, what is the time of New York? My softmax probability actually calculates the probability of the next word as part of the answer. So the probability of the next word should be, or the next sentence here should be, the time is this, right? So if you look at this as an example, so for example, I've typed in Humpty Dumpty sat. The probability of the next word is, out of all this, is on, because Humpty Dumpty sat on a wall. So this is exactly how any generative AI model works. It tries to predict the probability of the next word as part of the answer. So when on is predicted, what happens is that on goes again and becomes parts of the, sorry, my bad. I'll just quickly highlight something. I'll just take a pen. So what happens is that this on goes and becomes part of the input again. So I have on here. And what will happen is that it will take into consideration Humpty Dumpty sat on and try to predict the next word, which in this case will be the. And again, once the comes here, the next word will be wall. So this is exactly how LLMs, or in this case, any generative AI models work. Right? So, but till now, what we have just done is we have, one sec, I'll just quickly do a pointer. Yeah, that's right. So now what I've done is that I've just explained again a recap on what linear feed-forward network, the very basic architecture of what a deep neural network looks like, works. So now what we will do is that we will talk about the decoder model, right? So this decoder model is the crux of any GI application which works on sort of a decoder architecture. And this decoder architecture is sort of an enhancement on top of the linear network, right? So we have already covered the linear part of things, how it works, and how the softmax on top of it works. There are two additional components. One is this positional embedding, which is a key part of this decoder model. And the second is my transformer blockchain. So there's this called something called a transformer block, and then something called a positional embedding. So what we will do is that we will talk about positional embedding first, and then we will go into the transformer block. Yeah. So what is positional embedding and what is the core idea here? So the core idea is to use information about the order or position of elements in a sequence. So the idea is, so when I ask what color is the sky, I need to understand the position of the word in a sentence. So individual neural network. So for example, if I would have asked what sky is the color, that has the same connotation as what color is the sky. So there is no difference between those two. But in order for me to generate text, we need to know the position of individual words, right? So I know color is in the second position. I know word is in the sky is in the fifth position. And somehow I have to keep this information in mind in order to answer this question. right? So what I do is that I create two embeddings. By embedding, it's nothing but a numerical representation of each one of these words. So what I try to do here is that I try to take two embeddings of each word. I mean, nowadays it's more tokens than words, where token is a combination of characters. But for simplicity's sake, let's consider each word as one token. Okay. So what I do, I'll take the example of color. So for color, I have two vectors generated. One vector, which I just called E, which is just the vector embedding E, is just capturing the semantic understanding or the semantic information of this word. So I'm just converting into a 512 dimensional representation of this word, which is 532 dot 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 10. And this remains unchanged, irrespective of whether color was the second word, whether it was the third word, fourth word, fifth word, doesn't matter. My embedding for color will always be this. It doesn't change. So this is one part of it. The second part of it is when I try to calculate another set of embeddings or another vector which encodes the positional information, right? So what I am trying to do here is that we already have an embedding E for color, which was done in my last slide. I'm trying to calculate a new embedding PE, which is my positional embedding. And this is the function of which position color belongs to. So if you look at this, color belongs to position 2. So it's a function of this position. So if this position was 3, my embedding of color would have changed. If my position was 4, my embedding of color would have changed again. So the embedding of a particular word changes based on which position of the sentence it is in. And this is the formula of positional embedding. You need not take heed of that, but just see that it's a function of this I, which is the position. So depending on the position, the value of this positional embeddings change. Clear? Okay. So now what we're trying to do now is that we have two embeddings now. We have your original semantic embeddings, E1, E2, E5. We have your positional embeddings for all the 5 words. And my final embedding is nothing but a summation, which I'm calling it XPOS. Now it's a summation of your semantic information as well as your positional information. So this is how I am getting the positional embeddings of each and every word in my question or in my sentence. So this is one extra step that LLMs or any Gen AI models do on top of existing neural network architectures to enhance their positional understanding of the questions asked. Okay. So I think we have covered positional embeddings. So the second part, which is a big chunk, is this part, which is the transformer block. So after positional encoding, there is this transformer block, and this block is actually repeated 12 times in the original GPT architecture. Now it has been repeated 24 times, 48 times in other architectures as well. But this block repeats itself multiple times in any decoder architecture that you see. Now what happens inside this block? So this is a zoom in to the transformer block. So two major things happen. One is, again, a lot of terms I know, but this is something that we call as multi-head self-attention. So this is one key component that happens. Then there is a layer normalization which happens. Feed-forward is your normal feed-forward neural network, which we covered. The base neural network that we've covered will not cover this. And then again, there is a layer normalization. So the two new words that we're learning here is multi-head self-attention and layer normalization. So these two things happen inside the transformer block, and this is repeated 12 times. So now what is multi-head self-attention? So in order to know multi-head self-attention, let's understand first what self-attention is. Okay. So self-attention is nothing but, okay, I'll just give you the core idea because the maths is a bit involved. So even if someone is not able to follow the maths, at least the core idea should be clear to them. So the core idea is you find out how much to pay attention to every other word to build a rich context aware meaning. So again, what color is the sky? So I just don't want to focus on the position of color and the semantic understanding of color. I also want to see how much attention to pay to what is the sky, to all the other words, right? Because so instead of what, right? Suppose the question was what, the current question is what color is the sky, right? Suppose the second question is what color is the sun. So ideally, this word color should have a very high correlation with the word sun, because I want to know the color of this particular object. So ideally, this color vector should pay a lot more attention to sun or this fifth word rather than any other words in the sentence. Because if the is also omitted, my answer remains the same. If I just ask what color sky, the question remains the same. If I just say color sky, my question remains the same, right? So that's why I have to design the model in such a way that I pay different types of attention to different words preceding and succeeding words in that particular sentence. So in this case, I have to pay maximum attention to sky, then maybe to the first word what, and minimum attention to is and the. So this is the code idea, that you decide how much attention to pay to every other word, including the word itself, to build a rich, more context-aware meaning. But the question is, how do we do that? So for this, again, if you look into the paper, which is Attention is All You Need, so that was a very fundamental paper which started all this, talks about attention, self-attention, multi-head self-attention, so on and so forth. So what they say is that the key idea is transform the word, each of these words, into 3 vectors. So what are the 3 vectors? We call them Q, K, V vectors. So this Q stands for essentially query. So it means what am I looking for? So the current word's meaning, right? So what does color mean in itself, right? So that is what is called query. So query vector. Key means what I have. So what I have in the sense that what other words are there in my vicinity. So I have what is the sky, right? And how relevant are they to my own particular word, to this particular word. And then value is nothing but what is the value of these words. That is what is the actual vector representation of each one of these words. So we call them a QKV tuple. So Q is my query, that what is the question I'm asking. Key is what are the things I'm looking at to answer the question. And the value is the actual answer to the question based on all the other words. Right? So what do we do? So remember in the previous one, we got XPOS, which is nothing but your semantic embedding plus your positional embedding. So now once we have this XPOS, what we are doing is that we're trying to get 3 mode vectors out of XPOS. What we are trying to do is that in order to get my query vector, I'm multiplying the XPOS with my query weights. In order to get my key vector, I'm multiplying my XPOS with the key weights. In order to get the value vector, I'm multiplying XPOS with my value weights. And again, how are these derived? The same old backpropagation algorithm works. So when you train it against a known data set, you backpropagate the error and you try to get each one of these weights. Right? So you get this weight. So, and now once you have this weights, you transform each one of the words, what color is the sky, to now 3 additional vectors. So you have a Q vector now, which is XPOS into WQ. You have a K vector correspondingly, and also have a value vector. And you have the original vector as well. What do you do next? Next is what we try to do is that what I mentioned, right? So I need to understand what is the relevance of the other words with respect to, say, color, right? So how do I achieve this? So I take the query, which is the question in particular, so the query of the current token, and then I multiply it with the key of every other token. So remember, if I again have to write what color sorry, pardon my handwriting, but yeah, is the sky. So color has its own Q, K, V. Similarly, sky also has its own Q, K, V, and so the others. So what I'm trying to do here is that when I'm calculating the attention score, I am multiplying the query token with the key value of all the other tokens. And this is exactly to get how relevant the other tokens are to this particular word or token. So what I'm doing is that I'm multiplying this with the k of every other token, and then I'm trying to normalize this. I'm just using a softmax function to normalize this attention weights. And then finally, my attention weighted sum, again, these are all technical terms. So finally, my attention and my transform variable, which takes into care attention as well, is nothing but you take this attention weights and then you multiply it with the value of every other word. Again, I know it's a bit complicated because I mean, just grasping what QKV means might not be quite intuitive, but consider it this in the form that I have three vectors. One is the exact question, the query. The second is what are the different things that I have. And the third is the actual value, which helps me determine that how much attention should I put to each and every word. So this attention weighted sum actually gives me that transform variable, which takes into consideration what the importance of the corresponding or the others words before and after are. Right. So again, the weighted attention weighted sums capture the model's attention towards different parts of the input sentence. Cool. So this is just self-attention. So what have we mentioned before that we are talking about multi-head self-attention. Now, what does multi-head self-attention mean? So this is a very interesting concept that was developed a couple of, I think, 6 to 9 months after self-attention was developed. So this is called multi-head self-attention. So this is one level above self-attention. So what happens here is that, so my mathematics remains exactly the same. The only change is that instead of one self-attention mechanism, I use several heads in parallel with each other. So the idea here is that each head will try to compute or try to focus on different relationships in the input. So one can be subject verb agreement, that what is the relation, because if it's he, my verb should be has. If it's they, my verb should be have. So this might be taken care of by head one. So you have one head or a self-attention head which takes care of this. So you have a K, Q, V pair for this particular head. K1, Q1, V1. I can also design another head of self-attention which takes into care other linkages, right? So for example, if it's a male, it's he. If it's a female, it's she. So my second head, which will be K2, Q2, V2, this will take into account this particular relationship, right? So K1, Q1, V1 is taking care of one particular relationship. K2, Q2, V2 is taking care of another relationship. And you can have as many heads as you want. You can have K3, Q3, V3 to take care of another particular relationship. So the more that you take, the more complicated relationships this model can actually address. So what's happening here is that, so once I've designed each head, in this case, I've designed two heads, head one and head two, right? So I compute my KQ, V pairs and my attention weights individually for each pair. And what I do is that I simply concatenate them. So now I have, instead of a single K1, V1, Q1, I'll have a concatenation of these two, which will be K1, K2, V1 for now V2, and then Q2, V2, Q2, Q2, sorry. So now instead of a smaller K value or a K vector, I have a larger K1, K2 vector, V1, V2 vector, Q1, Q2 vector. And then I can keep on adding more and more heads. So I can add a head 3 here, I can add a head 4 here, and so on and so forth. And then increase the complexity of the model. The benefit is the more and more complex relationships it would be able to understand. Con of this is that obviously my cost for training this model will increase multifold. And secondly is that the more complicated the model is, the more prone it is towards hallucinations, right? So that's why we have to see what optimal number of heads suffices to build any such model. So one interesting anecdote that I can provide regarding attention and why this was caught and what finally led to building this multi-head attention and people understood self-attention is not working is, do we have a pen here? Okay, I'll just talk this through. So there was a sentence and the question was to interpret the sentence. So the question was, or the statement was, the man saw the astronomer with a telescope. Simple sentence. The man saw the astronomer with a telescope. That's it, right? So I'll just quickly maybe let me just write this down and just the man saw an astronomer with the telescope. Yeah. So now what was happening is, so the model was not able to understand whether the astronomer had the telescope and the man saw the astronomer with the telescope, or the man saw the astronomer using a telescope. This sentence can mean both the things, right? So it can mean that the man saw the astronomer who had the telescope, the astronomer had the telescope, whereas the other meaning can be the man saw the astronomer using a telescope, right? And this is exactly why where my self-attention, just a single head, was not able to capture both the meanings. So it was just routing to the first one, wherein it was just showing us the interpretation that he saw the man, he saw an astronomer, and the astronomer was carrying the telescope. It was not able to provide that different interpretation. Only when we added two heads, so we added H1 and H2, was it able to provide two different interpretations, both of which are correct to this exact same sentence. And this actually led to the advent of this multi-head attention layer instead of just having a single self-attention layer. So again, you have individual heads, you simply concatenate them, no other maths here. You just concatenate all your KQV pairs, then use a linear layer to project it. That's it. And then what are we left with? So we covered multi-head self-attention. We covered self-attention first. We covered multi-head, which is concatenation of the self-attention layers. And then finally, we have layer norm, which is nothing but short form of layer normalization. So what is layer normalization? Again, this is a much more simpler term than it looks like. So what happens is that what I'm trying to do is that, so as I say, right, let's consider each word to be a token. So what layer normalization does is that it tries to take each token's embedding vector and then just simply normalizes them. And what is normalization? For all of us in statistics, we know normalizing anything means that you subtract it from the mean, x minus mean, by standard deviation. As simple as that. So for every layer, what we try to do is that once we have this, for example, after we had this XPOS, remember, which was the sum of your E semantic embedding plus positional embedding, right? E plus PE. So after this layer, you normalize this XPOS. After getting the attention weights, you normalize the response. After every layer, you go ahead and try to normalize it. And why do we want to do this? Because when we normalize a variable, it becomes much more controlled. It lies within a given range. There is no overshooting of the data, or there is no abnormally large data or no abnormally smaller data. So they are well within a specified limit. It prevents things like, if I have to go there, in backpropagation, there is something called exploding gradients or vanishing gradients. So I'll not go into the details, but it prevents all those loopholes wherein you can fall into vanishing gradient problem, or you can fall into exploding gradient problem. But main thing to understand is that it tries to limit the outputs or each token's output within its layer within a particular value, and it tries to stabilize the values. So what we are essentially doing is that we are stabilizing training, allowing it to converge much more faster. So when I'm training this model, I'm converging it much less epochs than I'm originally supposed to. And the way is very simple. So I've just mentioned it. Calculate the mean and variance. You subtract the mean, divide by the standard deviation, and then you scale and shift it. That's it. And that is layer normalization. So I've covered all the three parts: multi-head self-attention, layer normalization. Feed-forward is my old normal feed-forward network. So you depend on how many feed-forward networks you want to fill it with. So this is my feed-forward network. So you have covered all the three parts, and then you repeat it 12 times. Why 12? So the more you repeat it, again, more down the line, more complex. So the more hidden layers, the more complex the model becomes, the more parameters you have to learn, the more it understands different relationships between different objects, right? So if you have to, say, translate an entire book, you definitely need that big of a chain or a neural network chain. So that's why it has been repeated. Again, 12 is just a number which was used by the original GPT architecture. So now you have as big as 128 times the transformer block being repeated itself. So this is the foundation on which any LLM architecture or GenAI architecture or decoder architecture is built on, right? And now there are variations. This is a base architecture. You see multiple variations in the architecture. So I just, this is my original model, which I just showed you right now. This was an explanation of this module. Now, if you look at other modules, right, I have just mentioned some of Llama 3, Olmo, which are open source GenAI models, mainly because, for example, Gemini does not reveal their source architecture. So there is no way of knowing that what is the exact route or the exact number of transformer networks, or what is the exact optimization that they've done with them. GPT was more or less transparent. Nowadays, they also do not share their entire architecture. But for open source models like Llama and Olmo, you will get details. You will go to their page and you can know their exact details, right? So for example, if you look at Llama, so instead of doing a post normalization, that once the weights are calculated, then only you do normalization, they run pre-normalizations, right? So that is one advantage. That is one difference that these guys, Llama 3 does. Similarly, there is one more concept called residual. I deliberately did not go into that because that is much more complicated. But what Olmo does is that it calculates residuals, and then within the residual itself, it tries to do a post normalization. Right, and then there are additional things like rope. Rope is another form of estimation mechanism or optimization mechanism that happens within Llama. Again, that is not in the scope of this particular session. That's why I'm skipping it. But if you see the base architecture here, right, that's exactly the same. So you have a tokenized text, you take its position embedding, then you have this multi-head attention model, you do a layer normalization, you have a feed-forward network, you have another layer normalization. This is repeated multiple times, and then you get to the final output. Right? So this is exactly how an entire decoder architecture works. And then I talked about rope, right? Rope is nothing but rotary positional embedding. So that is a different way of calculating embedding. So these are linear positional embeddings. Rope is nothing but rotational embeddings. Wherein so we looked at that sentence, said, what is the color of the sky? So instead of looking it in a straight line, what rope does is that it looks to it in a circular fashion. Again, there are advantages, disadvantages of that. I'll not go into that. But that is exactly how all the different variations work. But my underlying architecture remains the same, right? So I think that brings up to sort of a conclusion to what I had to talk about in today's lecture. So the main idea being that how an LLM architecture was derived from your original feed-forward linear network. It added positional encodings, it added transformer blocks. Transformer block included your multi-head self-attention, which is nothing but to get attention to, which is nothing but a module to pay attention to your preceding words as well as your succeeding words. Then you have layer normalization, which tries to make the training quick and allowing the model to converge faster by keeping the weights or the weights bounded to a specific value. And then we also talked about positional encodings, which is I want to understand uh, what is the embedding of a word in a particular location rather than just looking at the embedding of the word itself. These are the core building blocks of any LLM architecture. So having said that, I will maybe end the session. And yeah, that's all from my end. Thank you so much.
Thank you, Abhishek, for your nice presentation. It's really a nice hands-on. I'm sure that those who are really interested in this particular field will be able to get a lot of things. So it's time maybe for some question and answers. We have plenty of time. So those who are in the YouTube can write on the chat box so that I can translate or I can share the question directly to Abhishek. So it's the time. So could you please? Yeah. So one of the concern for this participant is to have the feedback form. Surely I will share just after this session. So before that, could you please share the questions that you have so that I can share with Abhishek directly? Or those who are in online mode within our Google Talk, Google Meet can directly ask this question. Any question if you have? Yeah, those who are in online mode can directly ask this question. So one question could be like, what could be the prerequisite for mathematics students or statistics students to start with data science, and how is the future for this in the age of AI enabled? So many things could be done automatically, but then how the mathematics students or the statistics students can do better? What should be the prerequisite that they should learn?
Fair question. Again, I think I get this question a lot, right? So in the age of agentic AI, so even statisticians also ask the same question, right? So what is the job left for us if the model itself can tell me everything? So, what skills do I bring into the plate, right? The interesting thing is that I've dabbled a lot in agentic AI myself, right? Where agentic AI truly excels at is that summarization of content, generating plans for you, providing you with a complete quality check of particular things, code reviews, etc., etc. One thing that GenAI still now cannot do is calculations and logical reasoning to that extent a qualified mathematician or a statistician can do. So what the thing that GenAI even makes a mistake, right? So if you don't especially if you give them a table and ask them to summarize this table, right? Where it has numbers in it, numbers being the keyword, right? Still now we see very sophisticated models like your Gemini 3 or your GPT-4o making mistakes or doing simple additions. It simply doesn't know which columns to add, which rays to add. And then every such GenAI generated report has to be reviewed. And more often than not, they're wrong. So when it comes to numbers, I'll still say that the hardcore logic or the brain that we put into generating insights out of these numbers, GenAI has not come to that stage of creating meaningful insights rather than what is obvious from those numbers. So our jobs are still safe. So that is why I keep telling folks. So definitely in that area, GenAI has still not excelled. Maybe it will go there somewhere in the future. I'm not sure. But till now, all those hardcore analysis, then deterministic, predictive models, right? So suppose you have to predict whether there is an anomaly or not, predict the forecast of what will be the sales of my item in the next week, so on and so forth, right? GenAI is not there yet. So it can give very generic answers, but it will not be able to do maths, do the base maths. So if you have to generate a time series, formulate a time series problem, and then determine the distribution of the time series, and then predict, GenAI is not able to do that. It does not. So that's the first question, answer to the first part of the question. Second part of the question, I would say the transition from maths to statistics or DS, right, is fairly simple, right? So maths is the fundamental principle behind all data science formulations, right? So as long as the maths is strong, data science is just about two things. One is just writing your hypothesis and then proving your hypothesis is correct or wrong, which is also something that we do in maths. The other point is, again, just formulating a business question into a typical machine learning problem, right? So I think, I mean, folks in mathematics are already quite poised in how to handle data science problems. So I wouldn't say that there are any prerequisites. So if you get your base mathematics strong across all the domains, be it supervised learning, wherein you try to solve classification problems, unsupervised learning, wherein you try to solve clustering problems, and then finally maybe the time series forecasting. So if all of these parts are covered, so I think no one needs to worry about. I mean, there are no prerequisites from maths to stats, but you need to have your maths straight. That's it.
Thank you very much for this query. Some more queries. I think, Abhishek, you are muted now. Can you just unmute yourself?
Am I muted?
Yeah, it's fine.
Oh.
Okay, so another question was, So you were talking about some framework in LLM. Can you brief about it?
Is this the agent development kit? So I'm not sure which framework you're talking about. If it's agent development kit, so you can just, so I already have this open, right? So you can just type in agent development kit in Google. So it will just give you a framework to get started, right? It also has a quick start kit, which gives you your agents, tools for agents. You can use this to look up how to just build a very quick agent for you. So this is a framework that you can follow.
Your screen is not visible.
Oh, sorry, my bad.
Shared.
Let's quickly share my screen once again.
Yeah.
Yeah. Is my screen visible now?
Yeah, it's now visible. Yeah.
So again, if you just quickly look up agent development kit inside Google, just do a Google search. It will give you all the detailed documentations of how to get started, how to build your agent, how to connect with tools, how to build custom tools. And I mean, this is sort of a tutorial in itself. I would just recommend that if you can go through this tutorial, you will have a very good idea of how to create agents and tools yourself.
Okay, great. Yeah, so there is another question. The question is, how do multi-agent system differ from single-agent automations, AI, in real-world applications?
Good question. So what happens is, again, I did not specifically cover multi-agent because that's a more complicated structure. And then there are protocols around multi-agent orchestrations, which is called A2A protocols. That is nothing but agent-to-agent protocols. So what happens here is that right now, the demo that I showed you was one agent, which was calling different tools. It was trying to call the weather tool. It was trying to call the time tool, right? That's it. It was one agent which was trying to call these tools. And these tools did not have any intelligence, right? So the tool was asked that give me the time zone for America. It was giving the time zone. The tool was asked, give me the weather for New York. It was giving me the weather. That's it. The tools do not have any intelligence. Now, what if an agent has to call another, I'll say a function, no, I'll just not call it a tool, while the agent has to call another function or another endpoint, which is also needs to be intelligent, right? So for example, again, as I mentioned in the previous example, right? So give me a plan for something which I can do in the month of December. So this is my core agent. Now this agent needs to fetch the calendar and also needs to understand that which days of my calendar are free. So suppose I have some important meetings in Mondays and Tuesdays, I cannot plan anything on those 2 days, right? So what this agent does is that another agent is created, which is called a calendar agent. And this is not a calendar tool, mind you, it's a calendar agent. And this agent has planning capabilities on its own. So this agent analyzes your calendar, finds out these are the days which Abhishek is free, and it sends it back to my original planning agent. So now my planning agent has called my calendar agent. My calendar agent has found out which days are free for me, and it has sent it back to my planning agent. Based on that, my planning agent is making the plan. This is a scenario where two different agents are interacting with each other rather than one agent calling a tool. And this is exactly where agent to agent orchestration or agent to agent architectures come into play, where both these agents are independent and they're doing multiple sorts of planning. So that's about it.
Okay, thank you. Okay, another question is, so for you, explanation and complex, yeah, that's not a question, that was a comment. So what is the importance of LLM architecture in data science? I think you have already explained a bit,
Yeah.
but so he has already explained. Any other questions? Where are the most important open research problems in agentic AI today?
Okay. Yeah, I think I also just touched upon this. So one of the most important, and that's still an open item, and people are trying, even we at Walmart are trying to solve this multiple times, is that how do we use agentic systems to actually do data science stuff? In the terms are how do we do forecasting using agentic systems? How do we do anomaly detection using agentic systems? How do we do table analysis, table insights, table summarizations using LLM agents? So to summarize, any calculation that involves numbers in it, not just text, right? Any calculations that uses numbers in it, how do we use LLMs to accurately solve for that, so that it actually gives me the actual summation is correct, the actual insights are correct, by actual anomaly detection is correct, and so on. This is number one. The second problem, which is a much bigger problem, is reproducibility of LLMs. So for example, if I ask the same question to an LLM twice, so there are parameters inside an LLM called temperature and all. Even though if I set them to 0, which means I expect the LLM to reply in a deterministic way, every time I ask the agent or an LLM a question, it answers in a different manner. So either there is variation in the word, variation in the content, so on and so forth. How do I design a system that every time I ask the same question, I'll get the exact same answer, no variations? So that is still an open problem in LLMs, and then people are trying to solve that as well. So one is business centric, that is summarization of tabular data, and then all these data science problems. And the other one is the code LLM problem, is reproducibility of LLMs.
Okay, thank you. Let's see any other question. Okay, no more further question. So, I mean, some few discussion might be because we have some little bit more time. So we have now 5 minutes more. So just, can you just explain, like nowadays the students, they're saying that, okay, we were mostly fond of data science and all because we have a good job prospect. But when you are in a quite a senior post, so when you go for some interviews and all, so what kind of questions that you ask that might be helpful for the students to learn, or at the very beginning when it's not always quite sufficient for our students to learn like the basics. Sometimes they have to be like tricky questions they usually ask for in interviews. So what kind of questions or what kind of preparations that the students must take from the very beginning so that they would be quite comfortable during the interview time?
Fair question, Professor Adhikari. But one thing that for campusing, again, for students, I would say that the pattern has not yet changed, because the things that we've learned over, working in the industry, obviously students will not be familiar with that sort of expertise, right? And again, for someone for a campus recruiting, I won't be directly going and asking them LLM questions, mainly because they haven't developed something on their own, right? Having said that, the one thing that, again, I talk about data science still. Agentic AI has not taken over all the data science problems, but it still helps to get a basic understanding, right? Not practical, but theoretical understanding of how these neural networks work, how agentic systems work, how LLMs work, so that, because that's the talk of the town, right? So every company nowadays will be saying that I am working on agentic, and they want to hire folks who are working in that front, right? Who knows that front. So theoretical knowledge, again, things that I explained right now in my lecture, right? So what does a layer normalization mean, what is attention, what is self-attention, then what is your positional embeddings. Things like these are typically asked apart from your original questions, right? So typically, what is a classifier? Explain different types of classifiers. So one thing I would say is that let us keep updated on whatever is the newest advances in the data science or the ML industry, while parallelly also having a firm theoretical grasp of the problem, it's of the mathematics of each one of these modules itself. That's one. Second thing that we typically ask are case studies, right? So that nowadays a particular problem might have millions of solutions, right? Given that you have LLMs, you have your traditional classical machine learning algorithms and so on. So what we try to do is that we give an open problem and then we expect the students to come up with a solution to that convert that into a mathematical problem. So if, and again, I mean, students can practice case studies. So for different types of case studies, if they can come up with what is the mathematical foundation using which they can solve it, it can be LLM, it cannot be LLM, it can be anything. But as long as they get their fundamentals right, I think that will set them up with a very good scope.
That's great. Sometimes the students ask me, like, so they have their normal courses, normal degrees. So will that be also helpful for them to have some extra courses like Coursera or NPTEL courses? Will that help them for getting a job?
Definitely. I mean, they have to be relevant, of course. So, for example, if there is a particular university where, say, the basics of neural network, I will not talk about LLMs at all. LLM is right now slowly being introduced into the curriculum, but say neural network is not covered. Suppose you go ahead and do a course for that in Coursera. They have to be relevant. As long as they're relevant to what is happening in the industry, definitely, that will definitely help.
Okay, that's great. Let's see any other questions. No, not yet. Any other question from YouTube people? And those who are still online in Google Meet. So I can see that still there are 42 live people are watching still. So I am sure that at the end of the day, it might be more than 300, 400, even more. I'm not sure. Let's see. The data will become when we close this YouTube channel today. Then the exact data will be available to us. So since we don't have any further question, let's thanks once again, Abhishek. Thank you for joining us. And it was really a great pleasure for all of us to have you with us. And I'm sure that the students have enjoyed your lecture, and we're thankful and hoping for the best for the next 2 days to come. And thank you very much for your kind support. Thank you.
Thank you. Thank you so much, Professor Adhikari and all of the others. So it was really nice to be able to talk here. Thank you.
Thank you. So we will very soon switch to our next technical session, the technical session 2. So it's supposed to start from 7 p.m. Of Indian Standard Time, but we have till 20 minutes to go. So if Eric wants to start a little early, may I request Eric to take whatever is your decision. You can start a little early if you wish. Eric Trell, who is Emeritus Professor from Linköping University, Sweden, and he is the Director of IMBIC branch from Sweden and Vice President of IMBIC as well. So without any further ado, it's my great pleasure to welcome Professor Eric Trell. So, sir, stage is yours.
Yes, thank you so much. And I'm so glad to be back. And the title of my paper is True Linear Algebra, so Standard Model and Periodic System. And there is a kind of battle which linear algebra is really true and which is first and which is original and so forth. So I have made a little expose on the line algebra subject here. And start immediately by the main person, in my opinion, which is Marius Sophus Lie, a Norwegian, a giant both physically and, as we must admit, mentally. And here he is wrinkled in a chair that is too small for him. And he was an athlete and man of the town in than Christiania. And he didn't think he should be a scientist, but he trained for the military services, but his eyesight was a bit insufficient. So thanks God, he turned into science instead. And then he awakened with astonishing vigor and capacity. And then happened some things, including linguistic and language problems. So the tendency is that that is overlooked. Anyhow, as I said, I took time now to make an exposé because usually I tend to talk so much in the start of the lecture that I don't come to the end. But here there is written, and I can say absolutely decidedly that Lee, he investigated the nature of Cartesian geometry. So if we think that dx, dy, dz are a bit meager and there are more exciting things, it's because it characterizes Cartesian geometry. So we must always keep that in mind. What he describes first and all is the universe we live in a very strict sense. It can't allow any, so to say, fuzzy. It must be absolutely clear. But then, on that clarity, we can make a lot of changes and transformations which come from that. Anyhow, he also said that Cartesian geometry, actually by handling the variables, settles a kind of algebra. So from the start, he understood that he was doing an algebra. And Cartesius also shared a view that was his, that actually, if there is an extension, if there is a line, it's a real thing. It's not an illustration, but it's a beam of a very concrete construction. Then came Grassmann, and he was earlier than Lee, and he invented linear algebra in a system that we won't say so much about now. But at the same time, also Plücker came, and he, as a geometer, he traded the gerade Linie as Raum element, and he shared a view that the line was a solid physical object. Then we have some quotations from Lee, and one very important one is that Cartesius produces a quantity system, x, y, z. He has among the unlimited manifold of possible coordinate systems chosen a definite one. And that makes this very easy for him, because you only have to deal with x, y, z, and dx, dz, and dy. Because that, so to say, describes and actually constructs the physical space we live in. It's another great invention he made was that he could, into this system, introduce a spherical geometry by sharing of infinitesimal generalities. So if you take the exact tangent to the XYZ space, you come into spherical space, which is kind of magic. So that's another of the solids and constants he used. So the object will, of course, since this is infinitesimal, be a straight line that is close to zero in length. So we go to next. And now we take it very rapidly. Ptolemy, he defined line as something that can't be taken in more than 3 perpendicular variations. And Grossman then, he came and he understood that there must be something called extension in space. And he took it macroscopically. So if there is, let's say, 1 kilometer, there'll be a line 1 kilometer long, and that will, so to say, make out an area of its kind. And if there comes another angle, it will also make an area, and that makes it very similar to the Hamiltonian kind of quaternion. We have Julius Krückel. He was also a scientist that first, interestingly enough, made observations of the solar rays and actually looked at the electron. But what he absolutely did, he said that the straight line, it is the element of space, and left it to Lee to give it its motor and clarity. So Lee's standard model here is the line of length equal to 0, and working digitally, step by step, as a differential equation itself. That is actually in the sense of Newton, who said that calculus must be composed by such asymptotically small straight lines. And working in Cartesian coordination, which we shall see then in the slides here, that really are only such steps. On the right side are some comments on this, which I perhaps won't go into very much. But then I have to come to William Kingdom Clifford, who created the Clifford algebra. Why is it so important? Yes, because he took Grassmann's kind of solution and put its size as vectors. So he created vector system, you can say, because Grassmann's never saw his opinion that there were straight. So this is a little. Now we can come to figures and see what are the Grassmann's. Yeah, there is first interior product, which is, and then there is exterior product. And I don't go into that, but it has the structure of and it has to come in 2 dimensions. It turns into a kind of cellular automata that goes out in the world and interacts with it. So it gets physical shape, you can say, from a kind of vector definition of vectors that has no actual physical structure because they are imaginary always. What is Lee's thing? Yes, the straight line of length equal to 0, they gather into the infinitesimal generators into this kind of structure, which then perform different. Either they could get out and come into transformation, but they can also step out in the symmetries, step by step, as we will see, and create the kind of structures you see in Cartesian space, from which transformations can be made. It's one interesting thing here that the vectors have either orthogonal inclination, and then they actually create the muon atom. Or they can have hexagonal inclination, and then they create more the electron kind of electromagnetic symmetries here. We come to this a bit better. So, transformations, they start with a sphere, of course. This is the identity. And then when they become subject to, for instance, collision and so, they can go into a volume curving ellipsoids because they will choose the kind of symmetry that they have. It actually is continuous because they also can choose other spheroids also. But the majority goes into this kind of regulated progress, which then gets it masked by the minor symmetries. It's all very precise and all very complete. And I won't go into that, but it actually illustrates what can be meant by a continuous transformation, and that there are absolutely endlessly many such variations. But I go to the other mode, and that is working step by step in Cartesian following and in also Newtonian following. It's a step-by-step line, but the only steps that are allowed in the Cartesian are dy, dz, dx, partial derivatives of x, y, and z, because it is an infinitesimal geometry. It must be a infinitesimal geometry, because the other geometries are based on points, and points are, of course, even more infinitesimal because they don't exist at all, actually. But a straight line that can be expressed as a distance between 2 points, that can be concatenated. So it can just go step by step. And then they can only choose to be one of dz, dy, or dx at a time. Let's say that it decides to be dy, then it will be a straight line. And let us say that there are only dy and dz, then there will be a square. But the big thing to do is, of course, to establish the Cartesian element, which is the cube, or perhaps also related. But anyhow, we see how it goes: dx plus, dy plus, dx minus, and then it comes dx minus, dy minus, dx, dy, and goes on to that without ever crossing itself. It goes on like this. And that seems very awkward, but that's a differential equation which you can't find any better. It's just something that it does to fulfill this task. But then we see that this won't be a cube. It will be half the cube. But now there is so that according to the rules of the game is that it actually comes into line congruences. The complexity of space means that any linear solution must have a linear congruence. That is a variety that is in a way mirror to. And when you put them together, and I have actually done that, but not in this variety, then they form cubes. So how shall they make cube already from the start? Well, they can't do it by themselves because they will diverge. So one half cube will turn away and they will divorce, as it were. But there are full of such things in the space. So they must meet. And then these cubes, they are very funny cubes because they are one wall, you could say, because the neighbor has a separate wall, but this wall. But that doesn't matter. And as we said, if there is a cubical variety, it's relating to the muon or orthogonal. But if there is more parallelism with the root of 2, as hey, there will be more hexagonal things and more like what encloses the electron and protons. And these two varieties are all created this way. But we also said that there was an identity of the tangential, and the tangentials are a bit worse, but they are the same. They are line congruences, so there are two varieties, and together they will create what we could call a current, something that occupies the same volume as the encasement, as it were. And when they come together, they form hexagonal structure. And the big idea is when now we have the cage and now we have current or the electricity, and if we put them together, what will happen then? Then we have, so to say, wave packets. Wellenpaket, as Schrödinger mentioned them. But here, being physical structures composed by themselves and of the space frame structure, the strongest construction element you could have. And you see here, this is only half, but you see there is the current and there is the cage. Just showing these pictures might set thoughts rolling. But now we come into a kind of difficult passage here. We have to explain that this characterizes early universe. And early universe also includes these hybrids where we have a kind of half cube combined with a half because they are like cones of each other. That is also explained in this dissertation. So we have halves here, half prepared for the combination. And in early universe, occasionally they meet, and then suddenly a complete wave packet is created. That contains both the packet, and inside this, it contains the wave. And the fantastic thing is, it's a contact transformation, and they contact in the cage, they contact along the sides, so it's just pressure. But in the current, they meet only in the edges here, in the corners, with a fantastic increased intensity. So that could actually be the difference between gravity and electromagnetism, kind of intensity and surface in the kind of interactions they have that surrounding. The interesting thing here is that by, so to say, piling themselves, they also pile the electricity in the same, because they meet in the corners and so on. So it's a kind of optimal packing thing also here. the same applies then if there only is the packages and the wave kind of vortices. This would come. So that is the early universe that is occupied by half by proto particles. And of course, if they collide instead, ipsilaterally instead of contralaterally, they will split up into, you can call the straight lines, which would be neutrinos, and the wiggly lines, which would be the photons. And we could even have quarks, which I shall come back to what are the quarks in this system. But anyhow, this can go on forever. They just occupy with a faint glow the early universe, and something must happen to make particles in a big quantity. And that, as we also know, in the faint background radiation, there turns to be small irregularities. And some of them will not make any difference, but some of them will, so to say, focus on themselves, and they will compress and they form stars and galaxies. And suddenly, the galaxies or the quasars or whatever explode. And this is, of course, a process keeping such half measures together so that they can be a great many such in the ejection. And we all know that particles are created in stellar catastrophes. So, no question. It happens in the stars. Why? Because this is a meeting place, compression place. So the big problem for this is, of course, to find a place in the universe, because otherwise it would be just a catastrophe, traffic catastrophe. That would be. They must find an optimal packing order that could continue to be packed, so that it doesn't be the biggest traffic crash already from the start. And there comes the next stage in this story, in namely the Bohr-Aufbau system. He did it by orbits, he did it by waves, regrettably, because if he had made it by solid or blocks, he would see that it will be creating a kind of further packable structure here that would contain also the electricity, if you call it, the current inside them. And the optimum packing is in the order 2, 8, 18, 12, 32, 32, and so forth. You know. And we also remember that there is a line congruence. That means that there will be a bottom variety and there will be a top variety. So there will be a double, what we can call module here. And we can look at the frontal of it, and we can see that here is the bottom and here is the top. And if you count the blocks here, we find 2 times 153, and that happens to coincide with the proton, electron, or even positron mass number. So we can say that we have the difference here between a rapid thing and a slow thing that takes one step when this rushes 130 feet, because then the block moves one step. So it's an inertia relation, because there are 12 lines in each block. So it is self-tiling, this structure. If you look at it from above, it's rhombic, and it generates a kind of light mosaic tessellation. The problem is only that it is obstructive in the sense that can't be taken any steps in it. So we must make it mobile some way. And that is also happening in, could say, physical processes that they might meet tangentially, and then they combine in this direction and create what more triangular. And as we said, they were wave papers, so they had the neutron part, and they would have the charge, which we then call proton or electron or whatever part. And yeah, then it's just to combine and put them together and see that they can start as the deuterium, but then they can be run together to become helium. And it's a bit more intricate than so, because I should not go into this, but there are also always all kinds of isotopes. But going on then with the second period, then we see that lithium will be formed, beryllium will be formed, all with the oxidation states here, boron, carbon, nitrogen, oxygen, fluorine, and neon. Neon is saturated because now there is no more site for it, so that is a noble gas. That was helium also, because that was also saturated. But this, apart from this, can be represented more simply by just squares and rectangles of surface. And we already know that there are some of them who are interesting in shape. For instance, carbon is mid-symmetric, and oxygen is also mid-symmetric in this representation. And we also have hydrogen from the earlier period. So we can see here that we have a kind of very interesting set here, which is characterized by mid-symmetry. And that would be hydrogen, that would be carbon, that would be nitrogen, that would be oxygen. They either could be surfaces like a puzzle, or they could be blocks like a mosaic. And this is the actual case. And they could have a lot of isomeric forms that could be. And now this is so interesting and significant that this is a building set of the organic chemistry. All organic chemistries, compounds, can be put together directly by these figures, all their isomers. If we see what happens with the other, now we come to third period. That is, that is, I can read it, but sodium, magnesium, and aluminium, and silicon, and so forth. We see that it has. But now the atoms seek a kind of quadratic. They don't want this mid-symmetry and puzzle things. They would just form blocks, square blocks. And we also see that loose neutrons and others can gather to this. Anyhow, I won't go into detail, but we see that there will be various kinds of modules. And how shall they, in turn, now build bigger blocks? Yes, this is by making an integral surface. Integral surface could be described as a Persian rug, a lot of knots, double knots, like wiggling through and coming back to origin and then popping up here. So there will be pile of Persian rugs composed to these. And then we have the atom. When we have equally many layers as the area here, or roughly so, this will be then radiated. We must make one provision here that imagine that it's very cold, then the integral block, integral surface will be very, very big. But imagine that it's very warm, like in the interior of Earth. Then there always will be no area here, but instead everything will go the vertical direction as it does also. So an atom can actually make a dance with itself in that way, which we always think, how the hell can it work in the inside of the world and then work on the outside? Yeah, that is temperature and pressure dependent. And that applies to all atoms that you can form them in this way. So then we have formed carbon. Let's say that now we make a self-aggregation of carbon, and then we can see that it creates structures which also include these fullerenes, yes, and looks like a surface of a graphene when you take pictures of it. And it can come in various kind of symmetries and form tubes and so forth and so on. And this is how it's photographed. Then it's just, there are balls and there are sticks, and then there is nothing. So it's a difference here in coverage. Now I shall be interested to know how many minutes I have. Sorry? Yeah, can you go to? Okay, so we take a lot of organic substances and they are written here and composed like this. And we take others, ethane, propane, butane, pentan, and it goes all the way to how many atoms as there might be. And it's very precise. And the thing is, as we said, that there will be isomers. There will be, for instance, already at C5H10, it's up to 13 isomers, and all can be traced here. There are various executions of identical chemical elements. And we go on. Here we have glucose, for instance, that takes care of C6H12O6 in a kind of specific orientation. And we have cellulose, which is a chain of glucose actually. And starch is also another type of chain. And now, if I, for times and as you say, didn't make a presentation, you could actually take any of these blocks and move it around. So it's made a computer system that have this as bits, pixels. I won't demonstrate that now. C6H12O6 can also be distributed as fructose. This is another constellation. And it could be galactose also, which is also a sugar of the same chemical formula, which actually was invented by Berzelius. So Berzelius is the only one who has ever made a kind of relevant chemical formula. Because we can see how is present chemical language describing, let's say, galactose, just by a system of balls and pins. There are the other shapes also, and I show them here, but they are absurd because they are not space covering, and they are creating structures that don't exist. Whoever saw a pin, whoever saw a ball. But that is how long chemistry's language has come. We can see cholesterol, for instance. That is very easy to construct from its formula here. And it's not space filling, but it's attachable to tissue because that lies here long and cover vessel walls and so on. We don't need so much time for this. We go on phospholipids, for instance. This is how their components, choline, phosphate, glycerol, fatty acids, are portrayed in present chemical formulas. But this is how it actually looks by a very precise combination of building blocks that can be combined longitudinally and which of course can form membranes. We can see here how ordinary chemical picture of this and how it really, as I claim, looks in society. And we have amino acids, for instance. They are trade now as small balls that come out of anyhow. They must, of course, have a specific width and specific also kind of inclination to be able to connect with each other. And usually they are forming bands, but they can also be formed into various other structures and form the proteins, which this is another organism, for instance. And this is then the big thing, DNA. DNA can all be made by this component. And we can compare this formula to the kind of formula it now has. And we have, this is RNA, because RNA is straight, but it can't really fill midline because it has too short uracil here to make a connection. But otherwise, RNA is forming straight modules and can be this was a bit for it. This was a bit hard for it here. Yeah, it can call. I won't go into this then. But now I just take for comparison. We saw organic, and this was what I saw. And on these small mRNA pieces. Yes. No. This was the big thing. Here. That took time. This took. Yeah. Nu kommer vi. Okay. So we leave the organic things and we said that the inorganic chemistry, that is kind of trying to create kind of square to which neutrons add to smoothen out edges and so on. That's why we have a neutron excess. And here I am now at the fourth period and looking on them. And now I am up at the fifth period in another scale, and illustrating how they move into each other, not anymore by nucleosynthesis, but by neutron capture. And here I look at some combinations. For instance, how does the chlorines of sodium, magnesium, aluminium, silicon, phosphorus, sulfur look? They just not on blobs or something like that, but they combine into space-filling structures. So, and complexes can be formed by, this is, by the way, the structure that Olof presented in Nature. Anyhow. And here we have come to the seventh period, which ends up in organesson. Organesson is the biggest atom, and it can be taken as the final slide here, which is this, which is a more artistic, if so be, illustration of the biggest atom. That is actually a noble gas, and it has noble gas configuration, perfectly rectangular. And if you count the grays and the blues and the reds and so on, you find exactly the same kind of neutron excess and orbit as in reality. And you can use them as a kind of keyboard to pick out them, and then you can compose them and put together various figures, either by fantasy or by chasing organic structures. Yeah, so this is actually the content. And I won't go into this, but I claim that actually nuclear physics and chemistry has a profound Nordic background. Jöns Jakob Berzelius, the Swedish, Marius Sophus Lee, the Norwegian, and Niels Bohr, of course, the Dane. And it must continue from this basis because the standard model and even the present of the periodic system valid. And they are more artifacts and you could say monuments rather than a kind of living science anymore. Yes, that would be the conclusion of the presentation. I hope it kept time reasonably, or I got 10 minutes more. I'm grateful for that. But,
Thank you.
I hope,
Yeah.
yes.
Thank you for your nice presentation and excellent images like every year that we see. Excellent new kind of atomic images that you every year we witness the greatness of your research. So now very quick question maybe because we're little running out of time. Any question from audience online in Google Meet or even on the YouTube channel? You can write questions here, or you can directly unmute yourself to ask this question. If not, then maybe at the end of this session, we can have the question altogether. So if okay, if there is no further question, I'm really sorry I got disconnected. If there is no further question, let's thanks Eric once again.
Thank you.
Yes, and now we directly jump into the next speaker, Dr. Christina Trell. She is a doctor and currently associated with Lund University, Sweden. And for IMBIC part, she is taking care of this bioinformatics and she is leading the bioinformatics part of IMBIC. So without any further ado, it's my great pleasure to welcome Christina. Christina, the stage is yours.
Thank you so much. And I will try and share my screen. So I will take it from my side if possible. Let's see. Can you see my screen now?
Not yet. Eric, could you please stop sharing your screen?
Yes. How do I do that?
At the bottom, you could have seen this stop sharing. Could you go to this meeting link?
Yes, but I'm off the meeting link now.
Var är den nu?
Stop.
Maybe on the here,
Let's see here. If I
Safari, on
can-
the Safari, could you please click on Safari or Chrome? I think it was open through Chrome, maybe.
Yeah, maybe. Let's see. Chrome. Let's see here if I can. Ja. Mm. Ja, jag vet inte. Jag får gå och se om jag kan.
Det är mycket bättre att ta på samma här.
Let's see if I can share my screen somehow. Even though it's, but you can't see my screen right now, is that right?
Not yet. Yeah.
Let's see.
Göra detta dummare. Man
Because
kan inte stänga av dina... Inte ens kan stänga av. Nu.
now let's see if I can. Can you see my screen now?
No, not yet. It's still
Not
very
yet.
Let's see.
Yeah. Now can you stop slide? Yeah.
And let's see. Now, can you see my screen now?
Yeah, it's perfect now. Yeah. So
Oh,
please.
finally.
Thank you.
Okay, let's see. I will have it in this view. Okay, so once again, I'm very happy to be part of this conference. And my name is Christina Trell, and I'm an MD and PhD at Lund University. And I currently work in the Infection Control and Prevention Office in the county of Skåne, Sweden. And we are basically trying to prevent antimicrobiological resistance to reach the healthcare system in Sweden and Skåne. And today I wanted to talk to you about a new threat to the healthcare system and the newest threat to antimicrobial resistance, which is actually a fungus named Candidosima auris. And fungal infections in humans is something that is very common. They are part of the human microbiota. So we have around 2 kilos of bacteria in our abdomen, and part of that 2 kilos is compromised of also fungal, different fungus. And the most common fungal infection is caused by yeast. Candida albicans is the most common species. And I think all of you might have experienced a nail or a skin infection caused by this yeast fungus. When we have patients that have compromised immunity or have gone through major surgery, then we can see more serious infection, invasive infections, which can cause a threat also to life. Before I move on with yeast fungus, I also want to mention that we can be sick by mold fungi such as Aspergillus also. But Candidosima auris is a species of yeast fungus, and it got its name from the Latin name of ear, auris, because it was found in a patient in Japan in an ear sample, and that was in 2009. And since then, it spread basically all over the world in healthcare facilities of different kinds. And it was declared a critical priority fungal pathogen in 2022. And with the same as other yeast and mold fungi, infections in human, we see infection mainly in the critically ill patient or the patient with heavy immunosuppressant drugs. And another problem with the Candidosima auris is that it's not susceptible to the most of the antifungal drugs that we use. So it's the same problem as we see with bacteria and virus to some extent, that they're not responding in the way we would have hoped to when we give medication against the infection. And it's important to remember that most patients that pick up this fungus as part of their hospital stay won't be sick. But in some cases, they can develop an invasive disease, and then you have a serious infection that is not sensitive always to the most efficient, normally used antifungal medicine. And in studies that has been made since 2009, the outcome when it comes to mortality has been quite high. So 30-day mortality in studies range from 23 to 67%. So it's a dangerous infection for the immunocompromised patients. And how many cases of this fungal infection do we have? the biggest problem is that we don't have an effective surveillance for fungal diseases. And as I said before, we carry a lot of fungus in our body, and that's normal. So to find this more dangerous fungus, which is harder to treat, is not always possible if you're not looking for it. But since it was discovered, Candidosoma auris, and that it has spread around the world, they have made a lot of studies to try and find how many carry this fungus. And when they have done these studies, they've seen outbreaks connected to healthcare facilities. And ECDC, which is Europe's CDC, they try to collect how many patients there have been. And since its discovery, it's been 4,000 cases in Europe alone. But then you have to remember that if you don't look for this fungus, you will not find it. So this is just the tip of the iceberg. But during the period that they have screened for this fungal infection, the highest rates is, as usual when it comes to these things, the highest in the south and the east of Europe. And of these 4,000 cases, only 6 of them come from Sweden. So far, we've been very protected. And another study looked more on the United States. And in this picture, there are some studies. And other places where they have found a lot of this Candidosoma auris, it's in India, South Africa, but you can see there's always also clades, different subtypes of this fungus that come from East Asia, also the Middle East and South America. And I read a study in South Africa and India, almost half of the invasive fungal infection is caused by this Candidosoma auris. And the cases we had in the county where I work, we only had 4 cases. So that's a big part of Sweden's 6 cases. And these cases all had connections to hospital stay abroad. And the first case actually came from India, from ICU, the ICU, intensive care units. And the second case we had was a hospital stay in Greece, also the ICU. And the last case we had, this autumn actually was connected to a long hospital stay in Saudi Arabia. And connected to this case in Saudi Arabia, we actually saw a secondary case at the same department in the hospital where this patient was placed in Skåne. So because of this and the development and the rapid increase and the knowledge that we only know the tip of the iceberg has they made it very important for us to create mitigation measures. And infection control is all about mitigation, really. And there are 3 key elements, which is detecting the case, it's having precautions for patient placements, so there won't be disease transmission to another patient. And it's also very important with disinfection and cleaning, because the big outbreaks in other countries is caused by having a lot of this fungus also in the environments. And it's been shown that this Candidosoma can survive in the environment for a very long time. So you have to clean it and disinfect all the surfaces to get rid of this fungus. And we have developed in the County of Skåne guidelines for screening. And the guidelines at this present moment is that all patients coming from an ICU in a hospital abroad outside the Nordic countries will be screened for Candidosoma auris. And this can change at any time. If we start seeing more cases, we will start screening all patients that has been to any kind of hospital stay abroad. It doesn't seem like this fungus is spreading in Sweden, but it's definitely spreading in Europe and the rest of the world. So that's why we need to keep track all the time how many cases they find abroad. And we do have isolation precautions. So as I told you, we unfortunately had disease transmission in one of our cases, but they didn't have the possibility to have single bed occupancy, and sharing a room made it possible for this fungus to transmit between two patients. So that's why we have to have very clear rules how to care for these patients. So single bed occupancy is what we recommend for these patients. We don't recommend anything except standard precautions to prevent the spread. It's enough with the normal precautions that we use in healthcare to prevent disease transmission. And the reason we know this is because we have studied all the literature and how to kill this fungus, and it's shown very clearly that it's normal alcohol-based disinfectant will kill this fungus, and in Sweden we use alcohol-based disinfection for hand sanitation, but also for disinfection and cleaning processes. So the problem with this fungus is not that it's difficult to get rid of, it's that you have to do it very thoroughly. And every time there is a risk of contamination of your hands, surfaces, or anything else that can lead to disease transmission. And I just wanted to finish off with there was like from ECDC, they came out because they're very worried with the rapid progression of the cases of Candidosoma auris, but they also wanted to remind us that it can be prevented, but it needs early detection, rapid, coordinated infection control. And that's what we've been doing in our parts of Sweden. And also the Public Health Office in Sweden is recommending the same kind of measures to prevent it from spreading. And the last slide was just to remind of the threat that we're facing with antimicrobial resistance. And I think you're all very aware of antibiotic resistant bacteria, but now we're also talking about resistant fungal infections that are not sensitive to the antifungals that we're using. So this will come at a very high price, both in life and money. So with that, I wanted to stop sharing, and I would love if there is any question.
Yeah, thank you, Christina, for your nice presentation and very informative. So if anyone has any question, please unmute yourself, or those who are in YouTube can directly type your questions on the chat box so that I can share this question to the speaker.
Well, I have a question.
Yeah, please carry on.
So the question is, how can we detect a patient CRS? What is the theme that one can understand that he or she has attacked by CRS? Can you understand?
I sorry, I couldn't really hear the question. I'm sorry. The sound was a bit.
Yes. Again, I am telling you. I'm asking you how to detect a patient attacked by.
Your voice is breaking. Can you? Yeah, we cannot hear you clearly.
Oh, sorry. Sorry. Still, I'm giving a big hand to you because you have told it very nicely and very beautifully, your topic. Thank you.
Thank you very much. And this is a very interesting topic, and it's all evolving, but it's also, I hope, not too pessimistic. I want also to show you that with measures, so we can still prevent this development from happening. And it's very important for hospitals in all countries to realize that infection control can be very effective when it comes to preventing the spread of resistant bacteria, virus infection, but also fungal infections. Thank you.
Okay. Thank you.
Thank you. I cannot see any questions from YouTube, but if anyone has any question, please write it there so that I can convey the question. Since currently we don't have any further question, it's our great pleasure to thanks Christina once again for your nice presentation. So it's a time for our next speaker. May I now invite our very own Carl Soup from US, Soup Inc. So without any further ado, it's my great pleasure to welcome Carl. Carl, are you there? Yeah, okay, great.
I am here.
Yeah, so we can hear you properly. Can you share your screen?
Work.
Okay, the small box and with an arrow.
I've clicked that,
And then
it says select the tab.
Yeah, enter screen, and then click on the box, the new enter screen box that you found.
Okay. I did something wrong.
Maybe
let me start over.
Yeah, you just click on enter screen, then a screen will come, a box will come. You have to click on that particular box, then only the share will be popped up. Otherwise, this will be deactivated. Enter screen, then you will find a enter screen on the left of a small enter screen box. You have to click on that, then the share screen will pop up.
Screen one, share.
Yeah, now it's coming. Yeah, perfect. It's done. Yeah, so we can
I go to full screen by
You can cut this agreement. Yeah, you can cut this. Yeah, you can just, yeah, fine.
Is this okay?
Yeah, that's fine. Okay.
Okay, ready to go.
Yeah.
What I'm going to do is talk, and when I run out of time, tell me, and I'll stop. Okay. The primary focus of this paper is to identify some of the basic temporal mechanics of time as a frequency per this research. Time is the curvature of 4D temporal space due to the presence of mass within the crystalline balanced system of systems, multidimensional fabric of space. As the crystalline MD fabric of space curves, 4D temporal space curves and produces a temporal charge. The presence of temporal charge within the crystalline and curved MD fabric of space causes plus or minus 4D temporal space to vibrate. The greater the curvature, the higher the temporal charge and temporal vibration. The crystalline MD fabric of space is assumed to be a separate entity from the objects within it. Earth equals 1 is the reference for Earth. Within the temporal spectrum, the temporal frequency where Earth experiences no time dilation is Earth equals 1. Per Jacob's ladder, Earth equals 1 is the baseline value as presented by the golden ratio proportions. Phi is to 1, what 1 is to big phi. Plus or minus 4D electromagnetic or EM space and plus or minus 4D temporal space are assumed to have similar orientations and characteristics. Color modeling of the visible light spectrum, or white light, will be applied to a proposed temporal spectrum to identify some of the characteristics of basic temporal mechanics. Concepts based on clock time T, or 1 second, are contrasted with those based on time being a temporal frequency that accommodates time dilation. Temporal frequency provides a solution to Einstein's twin paradox in time dilation as a black hole is approached. The universe is primarily defined by what we see per Earth equals 1 white light reference. Therefore, the universe is defined by what we see temporally per Earth equals 1 temporal white light reference. And so I'm going to do some jumping around here to try to tell a story, in a sense, to link things, because I'm not going to cover a lot of stuff. So stay with me. There is a possible correlation between time itself and gravity. And when I'm talking about time itself, is that the way we tell time is timekeeping. And it's not time itself. And from our timekeeping, 1 second doesn't address time dilation. Per this research, both are associated with the crystalline MD fabric of space. Plus or minus 4D temporal space is a subspace of the multi-dimensional fabric of space that I'm talking about. Einstein just approached it as space-time, the fabric of space, and I'm trying to distinguish the difference between space-time as Einstein expressed it, which is a three-dimensional matrix with 1 dimension of time. And I'm seeing that there's more to it than just 3 dimensions of space, and that space is filled with a vacuum. That what I'm trying to demonstrate is that space is a medium. And I'm trying to establish some of the groundwork or conditions that I'll have to meet in order to demonstrate that space is a medium. In the basic time hypothesis paper I did last year of this research, time was correlated with curvature of Einstein's gravity manifold. The time vector magnitudes of Einstein's gravity manifold were equated to hypothetical temporal wavelengths via the temporal slope value of plus or minus 40 temporal space x-axis. For Einstein's general relativity theory, gravity is the result of curved space and energy. The basic time hypothesis paper suggests that time is the result of curved space, charge, vibrations, and a primary tone. And what I've covered, curved space is gravity, one gravity. I addressed vibrations and I addressed primary tones, and I was having problems with charge because my modeling depicts a crystal or a fractal, and that gets you into what's called the piezoelectric effect. So when you strike a crystal, you get a charge, and if you apply a charge to a crystal, you get a vibration. And to figure out what type of charge you get when you strike a crystal, you need to know the piezoelectric effect coefficient, which would be the entire universe. And I was thinking, no, that's not where I want to go. But recently, here's some of the jumping around I'm going to do. What you can do to figure out the charge is that you can use Planck's equation, where energy or charge is equal to the Planck's constant times frequency. And that kind of completes, this issue of charge. And so now I'm talking about something that's Earth equals 1. And just working with this structure, it could help explain some of the large structures in space that we call like the cosmic web. What is it all about? Time as clock time T is a method of timekeeping, but time itself has not been explained, demonstrated, or proven by any other method of timekeeping. We have very accurate methods of timekeeping. We have very accurate methods of tracking our orbital period around the sun. This is our method of timekeeping. It is not time, just as we have very accurate methods of measuring and demonstrating gravity, but it's not gravity. So I tend to want to talk about curved space, and I ask people to keep their gravity equations in their pocket. And let's talk about curved space and see how we can increase or decrease curved space. And this is the geometry that I came up with in regards to the modeling that I'm doing. And this modeling also ties in with frequencies, where I talk about color, where I talk about the tones that are found in a chromatic system. So I have 6 peaks, or 6 primary colors, 6 valleys, and it gives me a total of 12 color references, and there are 12 tonal references that are associated with a chromatic system. A chromatic, or the word chromatic, means color. And so there's that correlation that ties in. The universe is defined by what we see or detect. The temporal spectrum is assumed to work like the electromagnetic spectrum. That's an assumption that I'm making so that I'll have something to work with. There's a range of temporal frequencies that equate to the visible light spectrum, and I'm applying that to my concepts of what time itself would be like. Temporal space and EM space have similar orientations and similar characteristics. The geometry that's associated with it are used differently, so I'm aware of that. But right now, I'm just trying to set up some of the basics. And so when it comes to Jacob's ladder, which is a distribution, a harmonic distribution, that if I can latch on to a value that I can associate with time, I can apply that to the geometry and get the values of other places within my hypothesis about time and end up with something that's testable, whether or not, is valid or whatever. And so for right now, I'm just making the assumption. So I'm aware that I have this conflict going on with my research, but stay with me. Third day of the conference, the problem's resolved. Jacob's ladder, to express it, if you have a baseline value and you're going up harmonically, this is the value that you use. If you're going down to a lowering octave or harmonic, this would be the value that would be used. I'm trying to skip through this so that I can just show you what I'm talking about. Big phi and little phi are irrational numbers. They are not considered transcendental numbers because they are roots to a quadratic equation. Examples of other transcendental numbers is pi and e. The system of harmonics and octaves of basic music theory begins and ends at the 7 o'clock position. A color harmonic or rising color octave in primary tone F uses the frequencies of the next higher color harmonic or a rising color octave to complete the primary tone F color harmonic or rising color octave. I know it sounds confusing. I'll show you in a moment. The reverse is true for color subharmonic or lowering color octave, see figure 201. Variations in temporal white light brightness. The approach I'm taking is that if I can describe color in the visible light spectrum, I can describe time in the visible light spectrum, and it'll result in a temporal reference within the visible light spectrum. So when we're looking out into space, we're not just looking at objects that are out in space, but there will be a temporal reference associated with it, so that if we're going to talk about how far away something is, we're not dependent on light that is time dilated. And therefore, we don't really know where something is or how it's working or what it's doing. And as far as primary colors, per this research, a primary color is the frequency in the middle of the identified range of frequencies for that primary color. And I wanted to just quickly mention about polarization, that if we are related to time and we have something that's our current moment, there's the potential that we don't live in the entire range of time. And there may be just like a harmonic that we are associated with, and things that are above and below our harmonic are invisible to us. And that two objects can exist in the same location in space, but at different times. And as far as how that relates to one another, it gets into temporal density. So things of lower temporal density, you're like approaching the speed of light, and time as a spectrum slows down, and time as you approach a black hole speeds up. And that would be the definition of time dilation. Earth equals 1 says 1 second is 1 second, no matter where you are in space. You're approaching the speed of light, you're still dealing with 1 second, or you're approaching a black hole and you're still dealing with 1 second. And I don't think so. Anyway, the rationale for what I'm doing is to demonstrate the feasibility of time being conceptualized as a frequency per the curved crystalline MD fabric of space, and therefore a temporal spectrum as represented by Jacob's ladder per a primary tone. So temporal space and EM space are currently assumed to have similar orientations and similar characteristics. The geometries of figures 101 and figure 204 argue that there are differences in their orientation, in the orientation of temporal space versus EM space. That difference in orientation per the geometry of the models is acknowledged. So I know it's there, but I'm not working that particular issue right now. This research has not been able to determine if the Earth equals one temporal vibrational rate is a single temporal frequency, or if it's the temporal frequency equivalent of white light. White light has no frequency. Again, just wanting to state that the MD fabric of space that I'm talking about is a medium. There's something there. Temporal density, this is the rate that time cycles relative Earth equals 1. The time vector magnitude equates to the temporal slope value, and see figure 202. What that's talking about is this. Vanishing points. So as mentioned before, things being out there in space, we talk about the current moment, and two things can occupy the same location in space, but at different times. And if you're dealing with time dilation, that's when that happens. The vanishing point is when one object or another object moves into another current moment to speak of, and it's as far as we can tell, it's gone. And when you think about how big the universe is, and that the last figure I heard is that we're only able to see 5% of what's out there, and the rest of it is dark to us. This may be the case, of what's going on, that we're dealing with time dilation. And let's see, I can adjust this so I can get more of it in here. This is the circle of fifths. And the geometry I showed you before was a hexagram, and that this is the vibrational portion that's associated to the geometry. And the primary tone F, a gift from Pythagoras in doing this circle of fifths, and that when he worked out the circle of fifths, you start with F. C is always at the top, F is to the 11 o'clock position. And one cycle around, it defines an octave. So wherever you start and you end up, it's an octave. And it's like a spiral staircase. So you come back to the same position, but you're one octave higher when you go clockwise. You go counterclockwise, you're one octave lower. And so in general, that with space-time, that you have 3 dimensions of space, 1 dimension of time. And with this model, I'm able to demonstrate that I have my x-axis, which is right here in the center. I also have my y-axis that's up here, the z-axis to the side. So I'm 3-dimensional in that respect. And so I'm also suggesting that I have spatial space, temporal space, and I have a electromagnetic space. And what this model also is showing is that it's all vibrational. it's all electromagnetic space. And I also have additional dimensions that I could add from Jacob's ladder, which would be the x-axis in the center. You have the YZ magnetic field, which is also current. You have the XY electric field, which is potential. You have your spiral staircase, which would imply torque. You have your color harmonics, you have your color octaves, and it goes on and on. So there's more dimensions that are there, and what I'm trying to work toward is that with the geometry that is applicable to this, that if I'm working with an equilateral triangle or red, green, and blue, when you combine red, green, and blue, you get white. So you have things balancing to zero. White or white light source has no frequency. And one of the problems that we have is that we have things going on, we can't detect it, but possibly the reason we can't detect it is that it balances to zero. And the other point, just talking about lengths of a string, that if you look at this, that D flat is where the octave begins and ends. And sunlight is in the key of F. And so the string for F comes around and ends here. And then you have to jump to the next string to complete your octave in F. And like D flat is the longest string that's associated here. The other thing that I want to point out is a question that I've had for some time, and that if the universe began with the Big Bang, then everything subsequent of the Big Bang would be what? Entropy, an increase in randomness. And when you look out into space and they take pictures, digital pictures, and they convert the light that they pick up into musical tones, I hear music, and it's incredible, the music that you hear. And I'm wondering, where's the information coming from? An increase in randomness should be absorbed in you hearing noise. But I don't know, it's just, where is the information coming from with the universe being as old as it is? And if it's increasing in randomness, so something's not, I don't know. So again, Earth equals 1 is a frequency where we do not experience time dilation. And again, sunlight is radiation. It's in the key of F. This is just another model of how I came up with temporal slope and temporal frequency, and assuming that the subspaces of the MD fabric of space are 120 degrees out of phase with one another. This could be the uniqueness that distinguishes temporal space from EM space from spatial space. And again, this is just another model I was using to express where I'm using slope instead of curvature. Einstein was using curvature, and tell you the truth, I don't understand Einstein. And I know people talk about they understand Einstein, and I don't get it. So a point of confusion this researcher has regarding Einstein's gravity manifold is that the fabric of space itself is a largely unknown component of space. Inner space, outer space, interspace. We know more about what is in the fabric of space or how it acts than we know about the fabric of space itself. Per relativity, space is represented or presented as being a three-dimensional coordinate system that has or may not be a vacuum. In the standard model of quantum mechanics, it is focused on atomic particles and subatomic particles. But what about the venue? And these are just some equations, basic equations that use T. And if T is variable, it creates a few problems. If time is a function of crystalline curve MD fabric of space, then time itself must be relative versus absolute. As in 1 second is not a universal concept. 1 second is in Earth equals 1 temporal reference per clock time T. I'm running short on time. And this is just overlaying the earlier structure where you have your hexagram in a made from equilateral triangles, and that a three-dimensional version of an equilateral triangle is a tetrahedron. So this ties in with also the ancient symbol of Metatron's cube, or hexagram with a dot in the center is a ancient symbol for the cosmos. And as a conclusion, I think I have enough time to read this. This paper expanded on the basic time hypothesis paper of this research by proposing basic temporal mechanics for the conceptualization of time itself as being a vibrational rate of curved plus or minus 4D temporal space within the crystalline curve MD fabric of space. Basic mechanics attempts to describe how something works. If something is crystalline, it means that the atoms tend to line up. If the crystalline MD fabric of space results from a the combined potentials of spatial space, temporal space, EM space, then the MD fabric of space could be a spatial, temporal, EM field with definable characteristics. This research, the subspaces are seen as system potentials within the crystalline balance systems, flat MD fabric space. The presence of mass, E equals MC squared, is not a given. When mass, E equals MC squared, is present, the crystalline MD fabric of space is curved, resulting in a piezoelectric response. Only hint at the diversity that this only hints at the diversity that is possible within the crystalline MD fabric of space. And again, comparing these equations, that if the things in space are defined by E equals MC squared, in the multidimensional fabric of space also has an energy component to it, that it implies a potential interaction between the two systems. But the fabric of space and the things within space are separate entities. Thank you.
Yeah, thank you, Carl, for your timely done presentation, as usual. So any question? So we are running out of little time. So any further question or comments, maybe very quick question we can take. Audience from Google Meet link. Anyone has any question? Okay, no question. Let's see on the YouTube. Can we have some question? Yeah, so one question is there, in what sense does curvature store information about past events in the space-time? Can you hear me, Carl?
I can hear you, but as far as past events, I don't know. I'm still struggling with the concept that time moves slower the faster you go. And therefore, where is something, and that would include information, where is something if it's time dilated? And if you go the other way, where you're approaching a black hole, which is to say that the curvature of space has increased, is that why light cannot escape a black hole? Is that the light would have to travel backwards in time? And if light would be considered like information, that again ties in with where are things and how does, space work? So I'm still at a very fundamental level on what's going on and how it works. And that's why I'm working with the mechanics and taking little steps at a time.
Okay, thank you. So I couldn't see any further questions. So let's thanks once again our very own Carl Soups from USA. So now it's the time to go for the next speaker. It's my great pleasure to welcome Professor Manoj Chatterjee, who is Emeritus Professor, School of Management, Birmingham University, USA. And he is an expert on peace sciences. So without any further ado, let's welcome Professor Manoj Chatterjee. Professor Chatterjee, the stage is yours.
Okay. Where is the screen share? Where is the screens here?
Okay, can you see a box with an arrow at the bottom?
At the bottom. Is the video setting, it says?
Yes, not in the video setting, but where you find this hand raised.
Share screen. Share screen. I see.
Yeah, click on that.
Okay, click on that.
Then can you see entire screen on the right side, top right?
Well, should I do the select first? Select the tab first?
No, just up the select tab. You will have the entire screen. Can you see?
Yeah.
Click on the entire. Yes.
Entire screen first.
Yes, entire screen first. Then all of a sudden a small box popped up.
Yeah.
Click on that particular box.
Okay, but I have this thing on at the top. Shouldn't I go use this thing like it is at the top? Yeah, got it.
Got it. Then share. Is your share?
Where is the share?
At the bottom right.
I don't see anything now, because it's the entire screen.
Yeah, after putting enter screen, click on the box. A new box popped up. A big box.
Yeah, I did. Yeah, wait. Now I can't do it though.
Yeah, so click on that particular enter screen.
Yeah, now I am on entire screen, and now I could see my share screen, but you can't, right?
No, you can see. Click on that share screen. Click
I don't
on.
See the screen anymore.
Okay, just a minute. You have clicked on entire screen, right?
Yeah, and then I clicked on my box.
Clicked on that box. Then at the bottom right, you have share.
No, it doesn't come. Should I close it or what? Closing then?
The cancel button is there. Can you see?
Oh, yes, no, I don't see any button. If I close it, this will be gone though.
Don't close it. Then can you go once again to the box with an arrow?
Let me go to your screen now. Okay, I got it here now. Now share. Should I say share?
Yes.
Can you see it or no?
Yeah, it's coming. Yeah, perfect.
But I don't see it.
Yeah, we can see your screen. Can you just?
But I can see it though.
No. You just put the presentation on your screen. We'll able to see this. Put the presentation.
Can you see it?
Yes.
Yeah.
Yes. You can see the presentation. Yeah. Okay. Yeah, it's done.
Okay, now I could go up and down with the arrows, right?
Yeah, you can go.
Okay, yeah. Okay, go ahead. Yeah,
Okay.
sorry.
Okay. This is Manas
Bobby,
Chatterjee.
can you hear me?
Can you hear me?
Yes, we can hear you. Perfect.
Okay. Yes. I'm speaking here from in New York,
No, New York,
not New York, in Dominican Republic, and then, uh, you know, uh, the one thing I just want to tell you, I have listened to this program for many years, 15 years, and also I suggested that the many things have gone up in other areas of social sciences, and I suggested that maybe in the future, to Abhishek and his late father, that maybe we can combine the type of thing, of the pure mathematics type of thing, and also the things you have done in economics, sociology, and then ethics and spirituality and so on. So many things have been done in that area. And maybe in the future, we can combine the type of thing what we are doing for the last 10, 15 years, and this type of mathematical modeling, and statistical things are going on, in other areas. I'm a mathematical statistician, but my subject is not pure mathematics. That's why I did not understand exactly how this can be done. But now I have some idea how other people are presenting the paper, and some idea how we can do that. But this is an extremely broad survey, and one area I just want to discuss, which I have a lot of work, including my work in the area of peace economics and peace science, conflict management and peace. The fantastic work have been done in the area of conflict management. Many people have done that using mathematical techniques and so on and so forth. They can use that new things which are discussing in the particular program for the last 15 years and put this together, about this together. One is the question of resource allocation, then macroeconomic stability, modern growth theory. This is the area of econometrics. Lot of work has been done in the case of econometrics, highly sophisticated, very, very sophisticated, but not connected with the material which you're discussing in this program. And so I'm just, these are the different things. I know you don't have time to find out for me to tell you exactly one by one, but these are the things he's going to. And then next, in peace economic, these are the different things. You'll be surprised to see that how much sophisticated work has been done by economists, and also like my professor Lawrence Klein, who won Nobel Prize in economics, and so on, many other people in econometrics, they have used this type of thing. It was very, very surprised how sophisticated they have done in mathematical modeling of in this area, but there is no connection about those things and the things which you're discussing in this particular program for the last 15 years. And next, you see, these are the different models. I don't have time to discuss each one of them separately. Models for water, world determination, and so on. Actually, they are number one thing is around. They're doing a regional science, geographical space, and geographical space. This is a very important thing. Information and mathematical modeling in geographical space, and that in that area. All the things have been done in pure mathematics have been a question of can be used. Unfortunately, none of those people who are working in this area, and also the people who are working in the area of discussing here in this meeting, they have done that together. I myself do not know very much about this pure mathematics. I know about the statistics and mathematical thing. So it will be a great thing for the future. Somebody will come and put these two together and be a more sophisticated overall thing in the future with Professor Abhishek, Odhikari. And then the different things. I don't in my books I have discussed this prisoner's dilemma. So geographical space. Now, number two is a question of conflict management and peace economics. Lot of work for the last 30, 40 years we have done in conflict management, conflict between different countries, and how it can be used, that type of thing. But unfortunately, many of the things which we have discussed in this program for the last 15 years can be used, which I myself do not know, because I do not know the pure mathematics part. But some people may be interested, about application of those, and also healthcare management. I have a subject. There's a paper today on healthcare management with somebody with MD, PhD, and the healthcare management is another one which can be used. So the Leontief model is very famous. I have used in my book in terms of COVID-19, how the mathematical modeling in economics, interrelationship between different sectors can be used in COVID-19. So econometric models, also I told you before, is a big thing, world econometric models, but we did not. My professor, Lawrence Klein, Nobel laureate, I worked with him, but we did not use some of the beautiful things which we are discussing in this particular model. And then next, you see, this is the arms spending and economic growth. There's a lot of work happening use of in CIPRI, for example, in Sweden. They have a lot of work done on arms spending and economic growth, defense contract, arms industry, arms export. All these things, they have a very high sophisticated mathematical models have been done, but not with the linking the type of subjects which we are discussing for the last 15 years in this program. Nuclear weapons, missile defense, space weapons, or weapons for mass destruction. A lot of work has been done in the area of this area. And then if you are interested in the subject matter, you can look at this book by Walter Isert, General Theory of Social, Political, Economic, and Regional, with particular reference to decision making. And then also another subject recently I'm interested in the course of disaster management. This disaster management is a very important subject which we started in Japan for the last 25 years, and the application of different mathematical techniques and different types of disasters, how can be included with the type of thing they're doing here in this particular program and the in the other areas. Another area which is very interesting to do is the question of ethics and spirituality. A lot of people are doing work in the area of ethics and spirituality. So it is a very important subject. And some of us are doing a work in the area about how the different theories and ideas in different religion and ethics and so on and so forth have been developed for the last 2,000 years, 5,000 years, how they can be used in the area of religious and moral perspective, international infrastructure development, security, and terrorism also is another subject where this can be used. So what I'm suggesting, that maybe somebody is in the future, we can put these two trees together. I think Abhishek's late father told me this, that maybe in the future, these two areas of things can be combined. Not only just the type of thing usually we are doing for the last 15 years, but also in the economics, regional science, peace science, disaster management, the ethics and spirituality, and so on and so forth, how this can be combined into the areas. Climate change, horizontal inequality, and so on and so forth. And then next. Yeah, you see, also a very important thing is a man-made disaster management. We have done a lot of work for the last 25 years in the area of disaster management. We have an international organization called Disaster Management Techniques, which is in headquarters in Japan. And for the last 25 years, I think, we have discussed a lot of work in the area of disaster management. But the question of the disaster and different other type of socioeconomic factors and also other things it has not been connected. And I have a very good idea about how these pure mathematics things, which you are discussing mostly here. There was a paper today on this disaster, the healthcare, for example. In my books, I have discussed the question of healthcare management, natural disaster, political instability, climate change, and all these things, global warming, and all these things can be put together using many of the things which you have discussed in this particular program for the last 15 years. Unfortunately, many people, they did not do together. And the question of civil war, horizontal inequality, socioeconomic inequality, horizontal inequality, political economy, natural disasters, and so on and so forth can be very much theoretically, they can be very much improved. I don't understand many of the things of this pure mathematics, but some people do. They can use this question of econometrics, regional science, peace science, conflict management, disaster management, horizontal inequality, all these subjects on international areas. Some people are econometrics, like my friend Prono Sen people this and so this here. What I'm writing this paper here, all this horizontal inequality, per capita income, horizontal inequality, globalization, per capita income, and civil war, Africa, and so on and so forth. All those things can be combined by using different things. And then
I don't know why is this. I don't know why this comes in. Sorry, your session expired. Please refer to the page to continue. Why this?
Can I continue? Rephrase.
Yeah, please continue. Yeah.
Okay.
Yeah.
Okay. Close keyboard is something. I don't know. You are presenting. I don't know what happened though.
Yeah, your presentation is not visible now, but your screen is visible. Can you just go to the presentation? That will be fine. Open the presentation, please.
Just do the present. Show my screen anyway.
Yeah, your screen is presented. So your presentation is not there.
Yeah, I don't know what happened. They won't let me present anymore. They won't let him present anymore. Sharing.
No, your screen is shared. So you just have to bring back your presentation.
Yeah, no, it's gone now. I don't know why. What happened? This is not our computer, actually. That's what happened.
Okay.
Can we hear? I can
say. Yeah, we can hear you. Please continue.
Yeah. We can hear.
Please continue the page. Presentation, they won't let you share after a while, though.
Yes.
Let me find the page. Yes, just hold on a second. He is looking for it.
Yes. You see, some of these, in the case of healthcare, for example, a lot of things can be done by the healthcare models which have been disastrous today. But
inequality, you did that, right?
Yeah.
And the disaster management, this are a model.
Yeah. Also, then question of technology management. A lot of work has been done in technology management. But what I'm saying that some of the very, very, very important things which I don't understand, the presented in the last 15 years in this particular program, it can be used in the case of this technology management and artificial intelligence. For example, I'm interested in using artificial intelligence in political science between the leaders of the countries and how they're doing this, and then differential equations and catastrophe theory, chaos theory, and then I don't know, something happened here.
They don't let us share the screen anymore.
Decision science, game theory, for example, gaming, coalition and bargaining theory, discriminant analysis, content analysis, graph analysis, Markov chain, all these things which we discuss in the statistics, but we did not get the connection of those type of things, the statistics, mathematical statistics, and the type of subject matter we were discussing in this program, excellent program, for the last 15 years. So what I'm saying, graph theory, content analysis, and the civil war and greed, and also participation by decision making together. Lot of things we are doing in the socio-economic aspects of social factors. Many things some people are doing in this area. Delphi method, asymmetric and incomplete information theory, artificial intelligence and expert system, a decentralization process, also ethnic conflicts in Africa, and so on and so forth. I think there's a lot of opportunities for very smart people who are presenting papers in this particular program over the last 15 years. Unfortunately, those things, those type of people in civil, in pure mathematics, they did not pay attention about the applications. I shouldn't say that. I shouldn't blame anything, but they did not do work in the area application of pure mathematics, in the applied mathematics, applied theory, in statistics, and so on and so forth. Those things I find out in the SONCA, the Indian Statistical Institute journal. Lot of fantastic things. Lot of things I have learned by attending this 15 years of this particular program, and I was wondering how I cannot do it because I don't have the background. But there may be some people who have the background in the type of things which are presenting here, and also simultaneously they have some ideas about the other things I said before about regional science, city planning, regional planning, urban planning, transportation. These areas they have done highly sophisticated work, but without the connection, without the help of the pure mathematics articles and things which are presented in this particular area. So I'm suggesting to my friend Abhishek, he's very, very young, that in the future, maybe we can combine these areas which we are doing for the 15 years in this particular program. His father was my friend, and we can combine this. This will be a fantastic opportunity for him. He is very bright, he knows what I'm talking about. Recently, I talked to him in Kolkata, in India, and he's very supportive about this area to have some areas, because some of the things we're presenting here, I don't understand because I don't have background in pure mathematics. Some of the people in the pure mathematics, they do not know what is happening with econometrics, for example. And this could be together. And this is the thing I just wanted to say before. And then if you are interested, I know that we don't have time. If you want, you can have a journal called Conflict Management and Peace Science. It's a very number one journal in conflict management. Our papers, Peace Science Society, Journal of Conflict Resolution, Journal of Peace Economics and Security. These are the different journals you can look and find out. Also, you can look at these about 36 volumes of books which I have edited in the area by Emerald Publishing by 35 years. And you see here, I can mention those things. For example, here, recently there's a book on COVID-19. I used the COVID-19 and like that. But one thing I'm interested very much now, because of the world, what is happening now today, is a question of application of artificial intelligence in political science between leaders and so on and so forth. But I don't know much about artificial intelligence, but there are some people who do, and they can use this artificial intelligence in the deliberation of leaders of different countries. They mean one thing, they do different things. Some things they say, but it are different things, other together. This is a outstanding work. I have work done on innovation, this type of thing, but I do not have in the technical capacity of the artificial intelligence. But some people do. Some people do artificial intelligence. But this application of artificial intelligence in peace and conflict management is a very important subject, and it's a very important thing. And then also the question of the psychology and theology and other things. This particular subject, we organized a meeting in Europe, in Sweden, for example, 25 years ago, in association with this ethics and spirituality, and it was blessed by the late Pope of Christianity. Not only that, in that Mahatma Gandhi, for example, I have established a center of Mahatma Gandhi Center for Conflict Prevention and Management, and this is there are many things in the religion and the stability and ethics and so on and so forth which you can follow and with follow with the things which you are discussing in this particular program for the last 25 years, to 15 years or 16 years of this particular program. So I know this is too much. This is, but Abhishek is a young person. He knows what I'm talking about. I had a talk with him. I mean, my recent visit to India, and maybe in the future, next one or after that, maybe we can we can invite people who are doing fantastic work in econometrics, sociometry, healthcare, and so on and so forth, and combine this with this type of things we are discussing in this particular program. And I do not have time. I know that I have almost finished my time, but I gave you the name of the journal, Conflict Management and Peace Science, for the last 25, 30 years. And then the Journal of Conflict Resolution, then has question of my 36 volumes of books on conflict management, peace, economics, and development, and look at the type of thing we are doing in those areas. But we couldn't do the type of thing I wanted to do because I don't have background here. And also, that's why it's a good thing for me to have education, to take part on this type of programs, to find out what those people are doing. But I cannot do it myself. But there are many, many other people who can do it, putting these together. This is the thing I wanted to say, and I know I don't have much time. And then maybe I wish Abhishek is great. He's a very smart person, and also the people who are discussing from Sweden, particularly in Japan, and so on and so forth. I have heard them before. That's very smart people. There was a paper on today. There's a paper on the professor MD PhD. I heard the paper, and they're a fantastic thing we're doing. Very, very good thing we're doing, and I hope in the future this is combines with but have a more broader area of the topic. This is my suggestion. Broader area of the topic, including geographical space, conflict management, then technology management, then artificial intelligence, and then a question of ethics and spirituality, and so on and so forth together, and put a more comprehensive in social science, subject matter for the future. Thank you very much, and we'll keep in touch.
Thank you, sir. Thank you very much, Professor Chatterjee, for your nice presentation. Any question or comments, if you have, kindly share with us, or those who are on online mode, YouTube mode, you can write your questions so that I can convey them directly to Professor Chatterjee. Regarding this conference, we have already increased the domain. Now, data science, AI, ML are also the part of our conference. So it was initially the maths conference, mostly pure maths and applied maths, then statistics. And now we have extended it to computer science as well, bioinformatics. We have also included this quantum computation. So tomorrow we will have 2 presentations on quantum computations as well. So we are also trying to extend, and also, as Professor already mentioned, about the peace sciences and ethics and spirituality, that will also take care of, because if we could make it in an offline mode, then we could have some parallel sessions, but in online mode, we do have very limited number of slots. So we cannot accommodate all of them, but surely your suggestion will be taken care of. Thank you very much for your nice suggestion, and hope we'll try to make it as much as we can. Thank you. And I cannot see any further questions. So the persons from YouTube, they have given you thanks, and it was a nicely presented and very informative session. They mentioned, thank you, sir, for your presence. Now it's my time to go to the next speaker. It's Dean Elzinga. Can you hear me, Dean?
Yes, I can. Can you hear me?
Yeah, perfect.
Great.
So he is from IBM Research, and he'll again be talking on how data scientists can adapt to the age of AI. Very important and very important topic, especially in the age of AI and ML. So we all are looking forward to hear from you. So Dean, the session is yours.
Great. Let me just set up, make sure the screen is, I want to share the second screen. So give me 1 second while we set that up here. Stop sharing. Presentation started. All right. Do you see?
No, your screen was initially shared. Now it's stopped.
There we go. There we go. Let's see. Sharing and start. There. That's what I want. Good. Okay.
Yeah, it's perfect. Yeah.
Now you're sitting. Okay, great. Great. Well, thank you very much, and thank you for the invitation to speak today. The talk that I'm prepared for you today is how a data scientist can adapt to the age of AI, and I work for IBM Research. I've been at IBM Research for 3 years. Let's jump right in. Let's see. Here we go. Wait, why is it? Oh yeah, here we go. Excellent. All right. So first, I'll give you a kind of an overview of what I want to talk about in this half hour or 25 minutes we have with each other. First, a brief history of data scientists as a job, from the sexiest job in 2012, and then just 10 years later, to big changes with the age of AI. And one of the big changes is that companies seem to be hiring fewer junior employees. So a bit of advice coming out of some of the results I found in researching for this talk is that data scientists should add AI skills and double down also on other vital skills that AI cannot perform. Also, that data scientists can consider increasing their programming skills and becoming, for instance, AI or research engineers. And that brings us to what my team does, our team. I'm a member of the team, and we all bring research models to users, to their audience. And we do that by taking those research models to production. And what I want to unpack for you is pick apart what are those steps to bring a research model that you might see published in a paper in order to get it to production so it can be used by an audience. And in particular, concentrate on one model called SMITED-IC, which is a model that does ionic conductivity. But I could have chosen any number of models that I've worked on this year. I didn't create these models, but I partnered with the model creators to bring those models to production. And I wrote the code that runs those models and runs them in production. So first, that brief history, a little bit of context of data scientist. Some of you may know that data scientist is a fairly new career compared to, say, mathematician or physician. Data scientists, you'll notice in this timeline, there's almost a 20-year jump, but from 1977 here, to 1997. Can you see my pointer there when I indicate with the pointer on the screen? Abhishek? No, that's it.
Yeah, we can. Yeah,
you can see the point. Great. But anyway, what I just wanted to get here is that it wasn't until 2008 that DJ Patil at LinkedIn and Jeff Hammerbacher at Facebook began to use data scientist as a term to describe a new kind of job category, a job category that combined statistics, computer science, and AI, and also mathematics. And my background, by the way, is 4 years of doctoral work in mathematics at UCLA and an undergraduate degree at California Institute of Technology, also in mathematics. So that third leg of mathematics is dear to my heart. Finally, in the beginning of what I think of as the heyday or the peak of the classical data scientist, this article in 2012 by DJ Patil, who back in 2008 had talked about data scientist as a new job category. He wrote this article or co-authored it that mentioned data scientist as the sexiest job of the 21st century, which made a big splash and is still an article referred to a lot today. And that leads me to the classic data science workflow. Let's look at the different steps that a data scientist, as it's defined, and when I got into the job, my first data scientist job was in 2017. And this sort of cycle was key to the work of a data scientist. You would start with problem definition. And that comes from understanding the business and understanding some pain point, but also knowing what kind of data your business collects. And then scoping and gathering that data. Once you have the data, you've got to clean it, or what I call here data preparation, and you might transform it. And that would be some sort of feature engineering. Then finally, once you have the data all ready to perform some more advanced manipulations on, you build models. And maybe one model, but it may be several models, and you evaluate them, model evaluation, in order to pick some that get to live on, perhaps in production, and can get used by other people. Then finally, that brings us to this step, model deployment and monitoring. That step's very important. I want to talk about it later. But that's the way we bring models, especially research models that are, first of all, designed to communicate with the research community. That enables those research models to be used by other people. All right, next comes the big splash, the happening in November 30th, 2022, that began what I'm calling in this talk the age of AI, and that's when ChatGPT was released. ChatGPT's release had a bunch of consequences, and I found some really excellent research papers from just the last few months exploring those consequences and how they affect the career of data scientists. One is that firms began to adopt generative AI very rapidly after ChatGPT was released. You can see from this paper by a couple of Harvard researchers in SSRN, they found the first graph here is the number of postings for generative AI integration by firms. And then the second graph is cumulative. So you take these, you can see these are small numbers in the 400s or so on the first graph, but then they accumulate here on the second graph. This plot shows how that over time, if you essentially integrate, those of you who know calculus, if you integrate this first plot, then you get this second plot from these researchers, and you see that the number of firms who are using AI in their business, judged by the fact that they've advertised for these AI positions, goes up and up. And now what effect does that have? Well, what these researchers did was they found that if you compare companies that use AI versus companies that don't, there was a serious effect on the employment of junior employees, people with less job experience. And that's this plot here. You can see this red line is the junior employees, and that starting right about the release of ChatGPT, there's a serious fall off, a serious decline in the employment, which is not to say the compensation. Apparently, the income still remains comparable and is not affected. But the number of jobs seems to go down, is what they found. But if you compare that to more senior employees, you see that there is no decline. Or there's maybe a bit of a blip right after the ChatGPT release. Maybe that's uncertainty as everyone tries to decide what comes next. But then it goes straight up again. Now, another set of researchers found something similar, but they concentrated on a cousin of data science, and that is software developers. This is another set of researchers, but it shows something remarkably similar, that up until ChatGPT, you see all of everything, all of these different cohorts. All of these are different age cohorts reflecting different seniorities of workers in the workplace. And I should point out that both of these researchers are drawing from US data. I know that's a limitation versus this audience, but it was the best results I could find from recent papers in this area. And I will get to some international and worldwide results in a second. But this again shows that the most affected group from these changes, from the adoption of AI, is the early career software developers. It's people aged 22 to 25. And this is from the paper Canaries in the Coal Mine, 6 Facts About the Recent Employment Effects of Artificial Intelligence. So what does that tell us? And what can we do to adapt to these changes? Well, one of the things we find is that Gen AI skills are more needed than ever. Let's take a look at what that need looks like. So it's true that Gen AI jobs began to increase right around, that is Gen AI meaning generative AI, not general AI yet, but generative AI jobs began to increase right about the release of ChatGPT. You can see that's this dark curve here. But much faster than actual jobs, complete roles built around generative AI, were postings saying that they wanted people with skills. So they were hiring for some other position, not a generative AI position, but they wanted skills in generative AI. Now, what do you think was the job that most mentioned generative AI skills in the job postings? Well, it's data scientists. Data scientists was the topmost reported, and these are all results from Lightcast, which is a company providing job research data. You can see that all these slides have references on them. But data scientist is the most prominent, the most numerous of the jobs where companies are listing the desire for generative AI skills. And so I take from this the advice that we as data scientists, we should all be learning generative AI skills, and we should be doing it as quickly as possible. I would further add that we should use AI to augment our skills, to broaden and lengthen our reach, but not to replace our work product. We have to watch AI like a hawk. We cannot trust generative AI, and so we cannot use it to replace our judgment or to produce the work output that we deliver to our stakeholders. Now, along those lines, another thing we can do as data scientists to adapt to this new period where AI simply can't be ignored is to focus on things that AI cannot do. What are those things? Well, these are the so-called soft skills, vital skills that a machine is just not in a position to perform. One of them is it's no substitute for our domain knowledge or subject matter expertise. If we're working in a drug discovery company in big pharma, then we want to know as much chemistry as possible. But the same for any other sector that we're working in, understanding the business that we're at and what helps that particular company that we work for succeed, the more we can do that and the more we can speak the language of our management and our executives, the more vital and irreplaceable we will be by AI. Stakeholder engagement. Data scientists work with other stakeholders all the time. And one thing that AI will not replace us is our judgment in building trust and alignment, so that when we work with engineers, with executives, we work on what is most important to them, and our insights and our work get used. We have to constantly improve ourselves in how we communicate and tell stories with data. The data will not speak for itself. I think Andrew Gelman said that we can credit the data when the data cleans itself. And finally, measuring business impact. This is something that we can do, but that we cannot get AI to do. We can measure how our work brings increased revenue, better efficiency, or how we satisfy and delight our customers. Now, what else can we do? Besides these soft skills, we can level up our programming skills. Let's take a look at the developer or software developer or programmer career. These are international data that I got from JetBrains, and you can see the reference at the bottom. In terms of absolute numbers, these are counts over time of software developers. And I want to make the point that developers or programmers outnumber data scientists, data professionals overall. And by the way, I do include us, data scientists, with those developers and programmers. For the purposes of JetBrains that grouped us all together, But just I want to point out that the set overall of programmers is 15 times bigger than the set of data professionals. And that's including data engineers and data analysts together with us data scientists. So the real number could be 30 to 1. A manager at LinkedIn once at a meetup told all of the group assembled that you have to assume for 100 engineers, there will be maybe 3 data scientists. So which group do you want generating the demand for your skills? Do you want it to be the 100 roles that a company needs to fill, or only the 3? What I'm saying is that by boosting our programming skills, we make ourselves more generally usable, more generally in demand, and we increase both our employability, whether we get a job at all, and we also increase our salary. We increase how unusual it is that our particular combination of skills. Here we can see that actual count of the data professionals, analysts, et cetera. Now, speaking of developers, 3 of the people on my team of 9 are data scientists, or we have been, and all of us are developers. So now I want to take a turn away from this advice and what we might glean from these changes that have come from AI and look directly at what my team does and how I've been adapting from previous roles where I did this classic data science workflow that we talked about, now to my current role as research software engineer, a role that I've had for 3 years. Let's focus again on that data science workflow, this cycle here. Let's see. Oh, I see we're getting close to time. Is that right? Yeah. No, we got. Sorry. So remember this slide, something like it we saw near the beginning. Now we're focusing on this model deployment and monitoring because I want to explode that and look at all the steps that make that up. First, a quick look at our team. We're part of a very small, relatively, part of IBM. IBM is 300,000 employees, and IBM Research is about 3,000 researchers and engineers. It's been around for about 80 years. It takes place in 18 sites in about 11 so-called labs. And these red dots, you can see, that's our team. That's where we live. So you can see some of us are in the Silicon Valley area of California, some of them in Los Angeles, which is where I lived when I joined the team, Chicago, you can see, and then I'm speaking to you here from the middle Hudson Valley, Poughkeepsie, New York State, and then also a couple of my colleagues. And you can see all of us. My team is here on the bottom: Phil, Ryan, Monin, Brian, myself, Derek, Dan, Narciso, and our boss and fearless leader, Srikanth Koneru. So you can see Phil is from Sydney, Australia. So and he works directly and closely with Monin, who's here in Greece, this red dot over here. So we're spread around, all of us developers, all of us with product management experience as well. Now let's look at those steps, the steps to deploy research models to production. Now, these are not completely standardized steps, but these are what we have learned, what I have learned as I've been working with model authors and helping to bring their models to third parties. For instance, I've gone with model authors to Cleveland Clinic to help researchers at Cleveland Clinic use their models in hands-on work sessions. And it was my engineering that was actually, well, my teams, that was making those on-site demonstrations and hands-on workshops possible. The 10 steps are, and we'll go through these by example, by taking a case study with one of the models. You got to meet with the model authors. Make sure you get, and to make these 10 things a little simpler, let's really think of these as 2. There's this sort of, there's gathering all the materials, and then there's writing the code and getting it in the hands of the model authors. And then finally, any end users, people perhaps even from outside companies. All right, so that first half of it, you're still gathering materials, meeting with the model author. I read their research paper. I get any code or checkpoints. Checkpoints are the saved versions of the model stored during training. Any data sets that are necessary. Find out exactly what the shape and type of the inputs and outputs are. That's step number 3. Make sure you get a test set. A lot of times the researchers will not give us a test set and we need to ask for it. But you need to know that once you know the types and we call it the shape in computer science of the inputs, that you also need some concrete examples and also to know what is the range of acceptable model outputs. A lot of times when you run AI models, they don't return even what you call deterministic models. One thing that's a little non-deterministic about them is that when you install them on different hardware, sometimes the floating point numbers you get back are slightly different. And so what is the range of acceptable model outputs? Make sure you know that and have at least a ballpark, or be ready to consult with the model authors later to see if that your test inputs are yielding acceptable test outputs. Make model code installable. Oh, this is important. When we get code from our researchers, sometimes it's a big pile of code and a big pile of data. We help them understand that if they work to make that an installable package, it'll save everybody time and make our lives much easier. I'll also hear a little bit of technical advice. Those of you who know programming or know Python, use UV. Don't use Conda anymore. I used to use Conda a lot. I suggest you use UV. It's just the letter U followed by the letter V. It's a fantastic project with excellent activity and support from the community. 6, build a prototype. This means just get the model running somewhere on my laptop, maybe on a cloud computer. I create an instance on AWS, and I just follow the instructions that the researcher has given us to make it run somehow. Once you have it running, then you can solve a lot of the other questions that might arise about how to write the code that's necessary to get that model running in production. And that's what we do next. We write the code for an API service, and the service is a program that's left running and is connected to the internet behind some sort of safety firewall. It's left running so that other parts of your system can communicate with it and send the data and receive the answer from your running model. That's the API service. And for this, I again have a technical recommendation for those of you who know Python. Use litserv. Litserv, which comes from the lightning.ai group. It's a fantastic, simply written, but also kind of beautifully done way to turn AI models into API services. Then step 8, we're almost to the end of these steps and we're going to jump into the actual model, is Dockerfile, Kubernetes deployment. Again, these are code, pieces of code that we write. We write them so that we can get these models running on production. And then finally, you test. Once you have this running in production, you test the scientific accuracy with the test code. Remember the test set we got from step 4. You also do engineering tests, like how fast does it run? How long does it take, for instance, to compute the ionic conductivity of 2,734 test set records? And finally, 10, you document things nicely. You use your best, put on your best skills for emulating excellent software packages you see in the open source community, and you write a good README, demonstration code, and test code so that you can share those with the model author and with your other users. Let's now take a look at the case study that I want to share with you, which is one of these models. Now, I could have chosen any of these models that I've worked on this year, but this is one I worked on very recently. It's called Ionic Conductivity SMITED IC. SMITED stands for Smiles, Transformer, Encoder, Decoder, and then IC stands for Ionic Conductivity. Now, what I love about SMITED IC is it's designed to help humanity, to help us design better batteries, which will help with energy storage and with renewable energy. When you have solar energy, for instance, you need to store a lot of that energy. Same with wind. And it does this by helping researchers discover electrolytes, which is to say the internal components of batteries, with increased ionic conductivity. Now, ionic conductivity is not the only thing that a compound, an electrolyte needs to be a good component of a battery, it needs other things like durability and stability, to resistance to temperature and other changes and so forth. But it is very important. This particular model, it is designed so that when they're done with it, they can use it. And this is what they actually did in the research paper, and which I credit here at the bottom of the slide. They screened 100,000 potential generated electrolytes. So these were generated automatically based on a screening of all the different pieces of electrolytes that could be used in electrolytes. Then they used their model, and you can see here they passed it through a fine-tuned and also the original SMITED for an embedding to screen, and the ones that the model said had higher ionic conductivity, they privileged those and did experimental validation. And by experiment, I mean they actually did this in so-called a wet lab and tested these particular newly novel compositions for electrolytes and found that they sure enough, they did indeed confirm that, like the model predicted, these produced a better ionic conductivity electrolytes. And let's look a little bit now at the technical pieces and connect it back to those 10 steps that I was talking about. In order to implement their model, the researchers created a customized input format. Remember, one of the first steps I talked about was inputs and outputs. Let's take a look at that input format. First, then I'll also describe that they then fine-tuned the original SMITED model. SMITED was built by training it on 91 million different chemicals from a public resource called PubChem. Well, they took this foundation model, SMITED, and fine-tuned it with a much smaller, compared to 91 million, 13,000 is a much smaller number of electrolytes. I see we're running out of time here. So, but that's good. We're getting there. And that produced this stage here, this fine-tuned stage. And you can see from the beginning to the end that we have a whole workflow here, a whole chain of events that needs to occur. And let me show you that input that input design. Oh wait, here we go, right here. All right. So each electrolyte has 6 different components. This first thing is a SMILE string, which is a way to describe a compound. Yep. And then followed by the percentage concentration in the solution, and then that's paired with a temperature. You can see it's a negative 39.4 or positive 29.4. Those are the inputs, and those were all devised by the researchers. And then the output is this single floating point number here you see. So inputs and outputs, connecting it back to those steps we had. That is SMITED IC. With that knowledge, then I wrote the code to make this into a service, and then we implemented it and deployed it on our production cluster. And here you can see some of the demo code and documentation that I wrote and delivered to the researchers so that they could verify that what I have running on production does exactly what they want it to. And then, here's some more of that code. I think the first thing we saw was the README. This is actually the notebook, which they just ran a couple days ago and said that they were able to run everything and follow my instructions and that it all looks good. So I was so happy. That's the end of this case study, but there's more to be done on this model. Now we need to find out, so far it's running on only one host, but if we want to be able to send queries from lots of people at the same time, we need to increase the number of hosts that it's running on. Other engineering changes in the future with increased engineering testing and feedback from our researchers. Now, a quick point out to other models that I've worked on in the last year, and then I'm just going to race through these because I wanted them to be part of the talk, and they're available. Several of them are open source, so you can actually download these models. You can certainly also look at the papers published by the researchers. There's NL2Opt, which takes optimization. For instance, if you state a problem like an accounting firm has senior accountants earning $3,000 per week and junior accountants earning $1,000 per week, if you state that problem in English and you want to maximize or keep the weekly wage bill below 150,000 and minimize the wage bill, then if you take that English language formulation and pass it through NL2Opt, it will run a program that it writes on an optimization engine and then give you back the results. Race cars, Neural Operators helps a company that designs formula race cars, and this is our team has produced the production version of this model, working with the researchers who created the model. You input a race car's geometry, and it predicts the surface pressure field and the surface shear field over the car's geometry, which helps avoid much more costly runs through computational fluid dynamics solvers. MAML helps design antibodies to treat illnesses, and this MAML was a model that I partnered with the MAML team at Cleveland Clinic to lead a hands-on demonstration and a work-through session with Cleveland Clinic researchers. And 3D grid VQ GAN, the last one that we'll look at, this and the next one are models that deal with the 3D geometry of compounds. And what you see is an electron cloud here, this first purple thing, and then it goes through, gets converted into just numbers, and finally just discrete numbers. And then even from those discrete numbers, which you can express as a little string, is able to reconstruct the original three-dimensional electron cloud. And one other three-dimensional positional graph neural network that I won't go into. And from that, I just want to thank you all for the invitation and for listening to my talk, and be open to any questions that there's time for.
Thank you, Dean, for your nice presentation. It was really great. The nice works that you did already is nicely explained. So any questions or comments if you have, please, those who are using Google Meet. Okay, maybe I could see some of the questions, the online. Okay, for students entering data science today, which core skill will still matter long term despite rapid advances in generative AI, and which skills are becoming less critical?
Well, for instance, if you are working on you used to be able to use some of these data sets, like the IRIS data set, these famous data sets, to produce projects that could get you noticed and could get you in the door. I would say that using data sets like that for your portfolio, and a portfolio is very important. So not just in your coursework, but when you actually think of personal projects that you can demonstrate to show what you do, make those personal projects count. Don't just do something that's run of the mill. A lot of the things that might have been usable to demonstrate your data science skills a few years ago no longer will work. So there's some really good blogs about what to look at for personal projects these days, and I would recommend investigating what is out there by searching on the internet for that. I would say start using generative AI tools as an adjunct to solving problems, but also as a part of workflows that involve those classic data science steps, because it's going to be important in the future to incorporate generative AI as an accelerator for your work.
Thank you. Let's see any other questions if we have. Okay. Okay, no other questions yet. But if I have some other questions, I will certainly convey to you. So
please, yeah, I'd be happy to.
Yeah, sure. And thank you very much for joining us. It was an excellent session, and thank you very much for sharing with us. And if we have any further queries, I will certainly get back to you and get the answers. Okay, thank you very much. That's the end of today's session, but I will be able to know exact count of how many participants has joined through our YouTube channel. Just after closing this YouTube, we'll be able to get this count. So tomorrow I'll be able to let you know exactly how many. I'm sure that it might be more than 300 or something. Let's see. how many it will. And thank you very much for joining us. Tomorrow we'll again start with the data science workshop. It would be at 5:30 p.m. of Indian Standard Time. At the same time, we will have before that we will have some parallel sessions on paper reading session that will start from 3:30 p.m. So may I request all the presenter to be presented tomorrow, to be present on time. Thank you very much. So wish you all a very good night or good morning, whatever, depending upon your geographical location. So thank you and goodbye.